Hey guys, we have received multiple grievances about the sound quality of many of our previous videos from multiple viewers over a long period of time. We paid serious attention and as a solution, we are republishing all the episodes from the TCL in VLSI series by digitally remastering the audio. In this marathon episode, we are clubbing 5 main episodes along with 6 Q&A episodes from the TCL in VLSI series. The starting episode explains the importance of TCL in VLSI and in physical design. The following episode demonstrates the installation of TCLSH in both Windows and Linux environments for hands-on practice. The rest of the episodes will coach you TCL coding with downloadable code links from the description of this video. So stay tuned, stay focused. Hey guys, welcome to the first episode of TCL programming in VLSI. So in today's episode, we are going to discuss what is TCL, domains of VLSI to use TCL scripting, why to use TCL at all, TCL scripting and EDA tool flow, how TCL script interacts with the design under test, TCL Application Programming Interface API methodology, various TCL interpreters, Hello World program in TCL, TCL Shell installation guide. Okay, so this is our menu for today. So let's begin. What is TCL? TCL or Tool Command Language is an open source, multi-purpose, interpreted, powerful dynamic scripting language. So this is an interpreted language and here you write a script and directly execute it. There is no need of compilation. Okay. And it's dynamic means you can change the code and then again source the code in the shell. So a powerful means this is a very powerful in terms of its data structures, etc. and all the controls. As well as in VLSI, it is powerful because it can directly talk to your design. So you have done a design through your software and you can directly talk to it with the TCL. That is we are going to discuss today. TCL is a fit for both small and large programming tasks. Means that you can write a 4-line code of TCL and source it in your tool's TCL shell and you can do it for a huge line of codes. So TCL by the name interpreted, you do not go to the conclusion, okay, we have some limitation. But TCL is very powerful and you can have a huge line of code as well as you can have a very small line of codes. Both will work. Widely used in various domains in VLSI design and verification. What we are talking about here is that the TCL is used, widely used, vastly used in various sectors of VLSI design and verification. So when I say design and verification means when you are designing, you can use the TCL provided that particular tool has a TCL interface for the designing purpose as well as when you are verifying the design, you can use the tool's inbuilt TCL shell to query your verification in particular. So you can do the verification and the design using TCL. So it subjects to the particular tool's shell and the corresponding available APIs. APIs are called Application Programming Interfaces. Later we'll cover today. So next slide we move. TCL shell found in VLSI. In which sectors? That is the first thing. As a beginner, a person who know nothing about the VLSI, this is very important for you because you are about to know in which particular fields the TCL is used and why you should learn TCL at all. Front-end synthesis tool. So in the ASIC design, when we are doing the RTL coding, after that we do the synthesis. In synthesis phase, in multiple tools from multiple vendors, there the TCL shell is available inside it. And there you can use your TCL scripting skill just to contribute in the designing. Next one is the backend placement and route tool, PNR tool. In various vendor tools, they provide a TCL shell for the PNR tool and there you can do some TCL scripting to automate your PNR process. And also sometime you can do query as well as some part of your design. Automation rather is a generic terminology that can be applicable to the both. static timing analysis tool, STA. So STA is used in both the front-end part as well as the back-end part of the ASIC design. And in both cases, you can utilize its tickle shell for your goal, to serve your goal, whatever you have. For back-end also, you can use. It's a common shell. It's the same tool, but STA is done in both front-end as well as back-end. And then there you can use your tickle skill here. Okay. So let's move on to the next point. Reliability analysis tool. Yes, many vendors do provide an interface where you can do the tickle scripting. Some vendors do provide to write the EMIR rules in tickle. So there the tickle used also. The next one is scripted waveform verification in analog. So in analog, the verification is a bit different from the digital, and there you can use different predefined commands, but they will be limited. In case you need to verify something of your own, the vendors provide the tickle interface to write your own tickle code to query into the respective data that you are looking for. So that's all here. And the next point is the design for testability tool. So DFT, we know that DFT is done for almost each and every design when that is done. So in design for testability, tickle is very widely used. And guys, here all the sections of VLSI that I have mentioned here, obviously the respective tool vendor will provide you one shell inside the tool where you can source your tickle code, and also a manual of the corresponding APIs, the application programming interfaces, which you can utilize for the same purpose. So let's move on to the next chapter. Why use tickle at all? So the question is, there are several scripting languages, and why we are talking about tickle here? Okay, why? Okay, let's see. Tickle script can integrate with major EDA tools with interactive shell of its own. That is, we have already came across. Cross-platform scripting support. So some EDA tools are maybe independent of the OS, and in that case, your tickle scripting could be done in one OS and you can reuse it in another OS, operating system I'm talking about here. So cross-platform scripting is supported. Data structures. Tickle provides built-in data structures such as lists, arrays, and dictionaries. Okay. In this series, we will be covering all of this. So you have to wait till that point. But this data structure are a very strong point of a scripting language. Why? Because when we are doing a design or verifying a design with your tickle script, you will get a huge amount of data, and to handle that data, you have to do the data mining, and that you can do with the help of the data structures that is inbuilt to tickle. You have to use the inbuilt data structures to deal with all the data that is coming to you as a response to your query, and you can manipulate the data at your own end to search a thing or a particular design, whatever your goal is. Control structures. Use built-in control structures such as if, while, for, each, switch, etc. So this gives a programmer a very much flexibility. Generally, whatever we do, we learn C as our first programming language. This is typical. Okay. And we came across all of this at that time. All of this almost are available in tickle. So tickle is well capable of handling these things. And once you learn one particular language, you come to know how to program your code, source code, so that to achieve your goal. And this if, while, for, each, all of this contribute in one way or the another to achieve your goal. So these are very important. So they are in tickle. Regular expression engine is robust as per Perl, Python, etc. So tickle has a inbuilt regular expression engine that you can use where it is used. So there is a huge number of nets in ASIC design. You are querying about particular type of nomenclature. So you can use the regular expression there to sort only those particular type of nets. So nomenclature wise. Okay. So that case you can use a regex. This is a typical example, but it is not limited to this, but you can use any kind of way that you want. Open source. Anyone may without charge download and inspect the source code of tickle. So you are there. If you want to see, it's up to you. You can see. So we are done with this section. Let's move on to the next section. Your tickle script and the DUT. DUT means design under test. Okay. So whether you are designing or verifying, we call it a DUT in this particular video. So how the things happen. So you have input file 1, input file 2, input file 3. So in this slide, I'll give you the information through infographics. That means the graphics as well as information from my end. When we design a particular VLSI architecture, right? So in that, we will have multiple files of multiple formats. They are fed into one by one into the EDA tool. So EDA tool reads all of these files. These are all important and necessary. And since this is a generic infographics, right? So you can understand that the tool will read all of them. And in today's design, it could be GBs or TBs of these files. Okay, so much data. So they are fed into the EDA tool. The EDA tool reads them. Okay, and the tool is alive. It combines the design that is under test as well as all the associated data and annotate them. So the design become live in your tool and it will have the design as well as all the data annotated. So the live design is now available to you at the tool shell. So here your design is live with all the associated data, everything ready to you. This tool shell is a very important part because here everything comes live to you. Live means the right away you query, the right away you get a response of any part of your design. That is why this tool shell is a very powerful thing. Now, you know the TCL basic things that we'll be talking about in this series. You make your script using the basic TCL syntax and the tool APIs. As I mentioned earlier, the tool APIs, that vendor will provide you a manual where the description, the input and output of the APIs will be mentioned. So combining all of them, you will write at your user.tcl, whatever your purpose is, whether it is a design purpose or a verification purpose, or you are doing something else. So what you will do, your tool shell is now ready and you source your TCL file in the tool shell. So your entire code is sourced. Source means here it is run. And if you have any procedures defined, you can separately then call those procedures one by hand also. Procedures are like C functions. So we will also cover all of these things in the entire series. No need to worry. So this is how the TCL scripting is placed in a ASIC or VLSI design. Okay, so you have the whole infographics with you. We have discussed here why the tool shell, when it comes live with the design and all associated data, is very important to you. This is why learning TCL is very important in VLSI. So this is kind of goal that we'll have. Okay, I learn TCL because I can use the TCL as a powerful tool at this stage when the tool shell will come live with all the design and the data. So we're done with this particular section. Let's move on to the next section. TCL code and data query. So I have just talked about that how in VLSI design we come up to the live shell. Now I will provide another next infographics here to make you understand how your query goes up to the design and comes back to you. So let's begin. Here the first outermost shell is your TCL code using API and basic TCL syntax combined. So definitely you will have to combine the API as well as your basic TCL syntax that you are going to learn in this particular sessions. You have ready your user.tcl. The next layer is, your code is interpreted by tools TCL shell when you source it. Then it passes through the VLSI tools API layer. It's a software concept. So just for now, understand this much is okay with you. So it passes through the tools API layer and reaches up to the design under test plus annotated data, live design. So these are the layers through which your TCL code penetrates. Now let's see when you make a query, what you do. Your query for design is invoked from your side and it crosses all these layers and go up to the live design. And from that live design, you get back your design data output. So this data output could be your design related stuff or verification related stuff or anything that is defined in the tools API manual. So the tools API manual will be separately provided by each vendor for each of their tools. So it do not have a generic. Okay, we do not have a generic API. It is specific to the particular tool and the particular vendor. Okay, so we are done with this particular slide here and let's move on to the next section. So long we are talking about API. So what is TCL API? An application programming interface. API is interface that helps interactions between the tool and the user written TCL code. So the interface words means there is a layer which allows you to communicate between the two different parties. So here the two different parties is one is you, another is the design. And the communication happens through your TCL code and the API. This is basically tickle procedures written by the software company. I was talking about just a few minutes before that each tool vendor will have their manual for their APIs for each of the different tools, and there is nothing called generic here. It is very specific. So if there is a same vendor, you have a tool for the front end that has a shell, so their APIs will be specific to that particular tool, and they have a backend. For backend, they will have specific API manual. So manual will vary from tool vendor to tool vendor, as well as for a same tool vendor, it will vary from one tool to another tool, because these are tickle procedures that is written by the software company. Okay. It also provides the features so that users can extend existing functionality in the various ways. So any tool, when they are written, right, their softwares, right, so they will have functionality, but when we are using an API, some additional benefits may be there. Apart from the design, query or verification, there could be some API that will serve this purpose. It defines the kinds of call or request that you can make to the VLSI software about the design under test. So these APIs will be described in the manual, and you will know about what set of inputs you have to give to the API to get your desired output. A tickle shell in VLSI tool provides live access to the preloaded design under test with all associated data annotated. So there is a typo here, please excuse me for that. So the tickle shell will provide you live access to the design. That is, live means it is live. So you will talk to the design live, and through information hiding, APIs enable modular programming. This is a beauty as a software point of view, that when tool has APIs, right, you cannot see the software codes which are talking to the design or integrating all the basic design data as well as the all hide data and annotating them. So you cannot see all these things. But the API layer, that is what I was telling about in the previous slide, that the API layer is a software concept. So the API layer will help you not to see the code. Obviously, these are proprietary softwares and not open source softwares. So here you will not able to see the software code, but still have the kind of powerful access to talk directly to the live design. That's all for API. Okay, we are done for this section. Let's go to the next section and see how the API performs. In this particular section, we will be talking about how to use API. Data dumping. So let's begin. Here, first your input query is entered through the API function. So API function here will carry out your input query. Your input query may be written in terms of the API function as well as your tickle codes, and this will generate scalar data, list or array, or lookup table. So lookup table could be two separate lists are interconnected, interconnected in 1:1 mapping way. So that will be your lookup table. So all this data can come up to you. The generic definition. So any API function may give any of these three kind of data output to you. And then you can use the tickle data structure to capture all this data, okay, and store them in the tickle data structure. And then finally, for your verification purpose or designing purpose, you can dump them in text or CSV file as you like or as you need. So the API function, this is a generic infographics that explains how our API works, tickle API works. Again, I am emphasizing that each tool will have its own API manual and you have to consult for each tool. But the generic, you are using your tickle skills with the interaction through the API, right, will exchange the data in this way. So your input query and the output of the API function will work in this way. So we can subdivide the entire this flow in a three-part section. First part comes the query that you are doing. Second part coming as the capture of the data. Third part comes as the dumping of the data in a hard code manner. So these three are the parts. So in the second and the third part, that is capture and the dump part, your basic tickle skill will be much needed because you have to manipulate the huge amount of data that is coming up to you, and that you can do with your basic tickle skills. And the query section, definitely when you work in a particular tool, you have to consult the API manual for that. And so you can see the capture and the dump part. Okay, so the data mining and the manipulation part and the storing, permanent storage of that data for verification, you need to learn the tickle basics. So I have emphasized and made clear to you. So I think this section we are done. Let's move on to the next section. Various tickle interpreters. So guys, in this particular section, I'll be just touch basing the various tickle interpreters, not the VLSI ones, but the in generic which are there where the tickle is used. Okay, so this is a list. First is expect, a tool automatic interactive system via their standard streams. Cisco IOS, the shell provided with Cisco network equipment. TCLSH, a standalone interpreter that is included with TCL. So this is we're going to install today. And this is throughout our series. You can use this one for testing the code if you're in Linux. Wish, a TCL interpreter with TK extension preloaded. It's a part of TK. So Wish is a GUI interpreter. Okay. We are not covering this in this series. TCL kit, all-in-one combination of TCL, TK, MetaKit, iTCL, TCL VFS, and a few other extensions. It is used for code in StartKit format. The next one is expect. Okay, so expect a TCL interpreter with the expect extension preloaded. It is created when building expect. Okay, TCL and WishX, commands that are included with TCLX. TixWish, included with Tix. BLTSH and BLTWish, included with BLT. tcl-doc, included with tcl-doc, and XO-TCLSH and XO-Wish, included with XO-TCL. So guys, you can see from this entire list, TCL is very widely used in multiple shells. So TCL is a language, but as a software, it can have multiple interpreters, and VLSI, it is also vast there. So learning the TCL will help you. So let's move on to the next slide. We are done with this particular slide. So your Hello World program. This can be done in the two way. First one is you invoke your TCL shell, okay, and right there puts, then within quotes, hello world, and it will echo hello world. So this is one way you can do your hello world programming. Another way, that is more intended way what we do in VLSI is that we create a script. We write #bang user bin TCLSH. This is the path where the TCLSH, the TCL shell, can be found, and put hello world. Okay, so then I'll come back to this point here. Let's see what we'll do after we have written this in a text file. Save the file with the name hello.tcl. Give it a executable permission by chmod +x, then hello.tcl, and run it as ./hello.tcl. So this way we can write our TCL, at least for this entire series. For VLSI tools, what we do, that interactive shell of VLSI or EDA tool, a TCL file is used as source, then filename.tcl. Okay, so your VLSI EDA tool shell is open, live, there you will source the filename.tcl. Now there is a catch here. Basic TCL can be scripted using the #bang user bin TCLSH, but your APIs that comes from your VLSI EDA tool will be interpreted by that tool's particular shell. So you can consult the manual how you can directly use in a scripted format. Okay, so that is up to the manual, but for this particular series, learning the basic TCL, you can use in this fashion. We are done with this particular section. So let's talk about the installation. So this is needed because in this series, when you are practicing the TCL, right, you have to have the TCL interpreter with you. So if you have a Ubuntu or a Debian, right, you can install in this way. TCLSH sudo apt-get, then space install space TCL. So this way you can install the TCLSH. So you have to keep your internet on and execute this in a Linux shell. Okay, bash shell or TCSH shell, anything there you can use it. Another important thing is installing the man page. By installing the TCL package, the TCL man page are not installed. You have to separately install them. This is how sudo apt-get install tcl-doc. So you have to separately install the TCL man page. It's up to you. Online man page can be accessed in this particular URL. Here it is shown, and also I'll provide this in the description of this video. For Windows, you can go up to this site, the activestate.com, and download from there. For other OS or distributions, if you are using, please visit tcl.sourceforge.net. So here it is all about the installation instruction. It is very simple. You can do it at your end. In case you are having issues, please comment. Hey guys, we are at the installation part here, and this is my shell. That is, I'll do the steps as the Ubuntu here. So here I have typed the statement here, sudo apt-get install TCL. And when I hit enter, it asks for me the password. I have given the password. Okay, so it checks that I have already the TCL shell installed and it is up to the latest version. Okay, so 8.6.9 plus 1. Okay, so I have up to date TCLSH. Okay, so I query it which TCLSH. From here, I can see it is installed in the path /user/bin/tclsh. And okay, let me do another thing. I'll do here. So again, I call this particular installation instruction and install the manual. So I am doing this sudo apt-get install space tcl-doc. Okay, so this will install the TCL's man pages. So here I have already installed it. Okay, since I have given the sudo password for once, it is not asking me because I have not exited this session. For this session, I can see that when I execute the installation command for the TCL man page, I can see in my computer I have the TCL man page installed. So this is the simple instruction steps that you can do in your Ubuntu or Debian package. Since I don't have other packages right now with me, I cannot show you all of them, but definitely if you go up to the internet and search, definitely respectively to your particular distribution, you can find the right commands, okay, for that particular installation. It could be RPM or it could be yum, anything, okay, that you have. Okay, so just to be sure that you install both of them, that is, one is the TCL shell and as well as the TCL man pages. Even sometime you can find that your TCL shell is installed by default. In some distros there it could be there, but be sure to install the tcl-doc, because when programming in TCL you might need to consult the man pages. So that is utmost important for you.
Hey guys, welcome to the 16th episode of Q&A. Viewer Kavya has asked in the 5th episode of TCL in VLSI series, I did not get any output for TCL script. Someone please show their output. P.S. I am new to TCL. Also, in a recent poll, you folks have voted and conveyed me that 20% of you are using Windows operating system only. So, in today's episode, we will go through hands-on installation and usage of TCL interpreter in both Windows as well as Unix operating system. Stay tuned till the end of this episode to know hands-on running of Hello World.tcl in both Windows and Unix operating systems.
Hey folks, here we are in our Windows operating system and I am using here Windows 10. So here I will install the TCL interpreter for the Windows. So let me type in the search box. So guys, you can see here that we have the first search result is active state TCL. Let me open it, another tab. So here you can see that we have options of downloading this. So for Windows, what we have to do is that we have to separately install TCL interpreter. For personal use, this is free. As a student, when you are learning this TCL, you can download it as free software and free usage. So here, let me click it. So guys, here I am registering and I have given my details. As soon as I log in, I can see here this is a MSI package is there. Right click and copy the link address. I will use my free download manager to download this one. And here I paste it. You can see as soon as I paste in the free download manager, it should start downloading. So here it is downloading, let it down.
So the download has finished. I'm closing my pre-download manager here. Here, go to the download. You can see apt-get is here, downloaded. Let me install it. I'm here going with the typical installation. You can go for complete installation also. Now, all in. So the installation has completed and I hit the finish button. So you can see that TCLSH has come here. Search in the box, the TCLSH will come. So here, let me write a tcl command. So this way in Windows, you can use the TCLSH. So folks, I have given you one particular example how you can do the pickle scripting in Windows. Here is your pickle cell. So if I do the pwd right, it is showing c/apt-get/bin. From this folder it is running. So if you keep any particular file here, let me create a file. So let me save it as a pickle. So here let me make a folder inside the active pickle. Example. And there I'll save it as Hello.tcl. So in Windows, we cannot use ls, we have to use dir command. So here you can see I have created this examples folder in which I have kept the Hello.tcl. Examples. Okay, so this will is the directory. You can see we are now inside the active pickle/example. Here what I did, force Hello.tcl, and that executed the code. This way inside Windows you can create a tcl file and navigate to that particular directory where you have saved a file, and then you use post then the tickle file name to execute that particular tickle code in the tickle shell. That's all, folks. In Windows, we have seen that how you can install the active tickle, and then you can write a file using the notepad and save it as a tickle, and then you can force that particular tickle command in the TCLSH shell. So I think we are done up to this point. Let's move on. Hello folks, we are in our Linux terminal. I am using Ubuntu and I have opened the terminal. Here I will install the TCLSH. So here is the command you have to enter in the shell, that is terminal, and I hit enter. So here you can see that TCLSH is there, it is already installed, and that's why it is showing that 0 newly installed. Okay, otherwise this same command will install this tickle shell. And now what I will do is that install the tcl-doc. So this is very much important. So folks, with this particular command I'll provide in the description, we can install the TCLSH in the Ubuntu system, and with this particular command we can install the tickle documentation, that is tickle man pages in the Ubuntu system. So let me go to my tickle test folder. So here we have our hello.tcl. Okay. You write cat and then leave the command here. You can see this file contains 2 lines. First is hashbang user bin tclsh, then puts hello world. So if I execute it, the clean code has executed. Another way, you can go into the TCLSH. The shell has opened, right? Here you can use in the same way that you have done in the Windows. So in the same fashion, in Windows you have run source then hello.tcl, and in Linux you can also use source hello.tcl. So this way you can run a tcl script in Linux. Folks, we are done here.
Welcome back to the second episode of tcl programming. In this episode, we are going to discuss variables in tcl, if-Elseif-Else condition, while loop, for loop, Foreach loop, switch case, procedure, scope of variables, Upvar and example. So this is the menu for today. Let's begin. Variable in tcl. So we will discuss this thing by example. So we start our script by the hashbang user bin tclsh, and here we set money equal to 1900. The syntax is set space money space 1900 then semicolon. Then we write puts within quotes money is $money and we end it with a semicolon. So this way a variable is defined and it can be printed. The similar way we define A with the value 10, and next what we do, we set B within the triangular bracket, we write expr $a plus 5. So this is a mathematical operation on the variable, and the expr is a procedure, predefined procedure in Tcl, which gives its return value, and any procedure in Tcl, whenever it is giving the return value, it has to be executed within these rectangular brackets, and the output can be saved in a variable or a list or an array or a dictionary. So here it's a scalar value, so we are storing it in a variable b, and here we can echo a and b by the puts command. Here with this unset command, we can undefine the value of a. So any value that was stored in a now is completely undefined. And if we again here execute that echo $a and $b, $a will return nothing. Next one, in a if condition, within the checking has to be within the curly brackets, and here we are using the info exist a. Now what we have done, we have unset a, so we are checking if a exists at all. So info, this procedure will return a 0 value once this checking is true, and when we use a bang, we negate it, and we use that in a if true condition. So if the a variable exists, what we'll do, that will set a with 50, and we close the if, and then incr a. Now incr, it's another procedure, it will increase the value by 1 of a. So now you can have a task that you comment out the unset condition and check the rest of the things, and you can, without a comment statement, you have the unset and execute this thing. So you will see the difference. This is a tried and tested code, so this is a task to you, do it at your end. Here, then again we echo $a and $b. So this is a brief description of any variable that is being declared, that can be unset, that is made undefined, and we can check whether some variable at all exists or not with the info exist command. Guys, this is just a first glimpse of the variables in Tcl. Mostly here we have dealt with the scalar variable. So we're done with this particular slide. Let's move on to the next slide. So here we are talking about if-Elseif-Else. Now, before going into the example, I would like to mention that here I have covered the all, that is if-else and if-Elseif-Else. So I am not separately showing you the if-else condition, because if we remove the else if from in between, the if and else will execute as usual. So let's begin. So here our hashbang command is there, and then we have set x equal to 1, that is set x space 1. And we are checking the if condition, and the condition of the if have to be checked within the curly brackets. If $x not equal to 1, what do? We echo that $x is not equal to 1. Else if $x equal to 2, what do? We give the puts command with the value that $x is 2. And else, if neither of these two happen, in that case, put $x is 1. And we close the else. So here you can look at the structure. The intent of this particular slide is to make you familiar with the if-Elseif-Else condition block, how to write the conditions there. Here you can see I have used not equal to and equal to. These are almost similar and are very common in the various programming languages. You know that. So here you can use them as a conditional checking within the curly brackets. And to be emphasized one more point here, when the condition curly right bracket ends, after that you give a space and then write the next curly bracket. So this has this syntax you have to follow. So here I have used, and here I have not used the semicolon. You can use it or not use it, but better you use it to follow a particular convention. So we are done with this thing. Let's move on to the next slide. The while loop. So here, before showing the example, I have demonstrated here the basic while condition, how to write the condition, and inside the different controls I have shown. So I'll show the example and explain. So here we begin our script with the hashbang command, and we set I with the value 0, and then write the while condition. So here, like if the condition is put into the curly brackets, $i less than 100, and it starts the body of the opening curly bracket starts the body of the while. We use the incr I, that means the I will be incremented by 1 value. And if $i equal to 85, what we do, we echo that a is, so $i is now 85, and we continue. Else if $i equal to 90, what we do, we echo I am getting out of the loop at I equal to I. Now here you can see that the else if condition is also used. And here we use the break. So these are the two control keywords I was talking about in the initial part. So this way we can use continue and break to continue or come out of the loop. And here we write the else condition. Apart from these two conditions, what it will print in the screen that I am at count $i. Here we are closing the else. And here we are closing the body of the while. So guys, here I have shown the typical example of a while loop, the initial condition, the counter that controls the while, and then the continue and the break statements that are well-known concept from, if you have known C, right? So this is a well-known concept. So all these things I have covered here. So we are done with this section. Let's move on to the next slide. For loop. So here, before beginning, I will be showing a couple of examples of the C-style for loop. So let's begin with the first example. So here, what we do, the first line comes and we are doing the up counting here. Okay, so for set I 0, so this is the initialization counter, then the condition checking counter $i less than 10, and the third one is incr I. So you can relate if you know the C language, right? That there are three counter and it's a typical C style for loop we are writing here. First is the initialization counter, then the condition checking counter, and third is the incremental counter or decremental counter based on whether we are going in the plus or minus direction. So now the body of the for starts here, and here I am printing that I am at count $i and going up. So after 200 and we say update. So these are two things that are not related with for, but just here for printing I have used it. So what this do, that this after function or the procedure, it does what, it delays the display for 200 milliseconds, and when after that we say update, then the display comes. So sometime we may require this, so that with this example I have shown to you. Here I have just closed the body of the for. So this is a typical C-style example of for loop. So this was the first example. I think now you are familiar with the for structure. Let's move on to the next one. So we start our script here, and this is for down counting or decrement by 1. Okay. So here we write for set I with 20, initialize I with 20, condition is $i greater than 0, and we use in incr function, so incr I with -1. So we will be decreasing I by value 1, integer value 1 at a time. So okay, so now the body start, it is similar to the previous one. We are printing the value, and after 200 milliseconds we are updating it, and we are closing the body. So this is decrement example. So I think it self-explains you why I have shown the example, and let's move on to the next one. So here we are starting our script for increment other than 1. So here we use for set I with 0. Okay, this is the initialization counter. Condition counter is $i less than 100, and we use incr I 5. So this I variable will be incremented with integer value 5 at a time. Instead of increment of 1, it will increase with the value 5. So anything. Similar way we can use a decrement operator here also. This is to make you familiar and well know the for loop different three parts of the initialization, condition checking, and increment or decrement counter. Okay, so the body is same as before, and we are, I think, good with this. And so it will increment I with 5 each time, and it will print. So we are done with this particular example. Try at your end. These all are well tested scripts. So I think once you try it, you will become more familiar, and do experiment and comment me whether you are exploring something else. Okay, please comment. That helps your and mine interaction. Next one is the Foreach loop. So Foreach loop, before beginning the example, Foreach loop is widely used in different scripting language, and Foreach loop operates on a particular list or array, right? So where it picks up one element at a time, and on that you can do any operation. Let's begin the example. We start our script with the hashbang command here, and we operate on Foreach. I am writing color, then red, orange, yellow, green, blue, purple. So these are list of colors, and the list is defined here within the curly bracket, and in the body begins after this. Okay, so in the body we are writing puts $color. So Foreach loop will pick one color at a time, and it will print the color name, and after 200 update. So it's simple, very simple, the Foreach loop, and you can try it at your end. So here we have defined the list inside the Foreach itself. So we are done with this particular example, and it is very simple to understand. So try it at your end. So let's move on to the next particular example. Okay. So here we are starting our script. Okay. we are doing what? Defining a list separately. In the example we have just seen, we have declared the list inside the for each loop. And in this particular for each loop example, we will be defining the list outside. Okay. So we define a list like this, set lst colors, and within double quote, space separated values I have given for all the colors, red, dark, yellow, green, blue, purple. And here I am using this particular list for each color, and since I am using the value of the list here, I put a dollar here. So dollar lst colors, and in the body I put the color, and as usual after 200 milliseconds I am updating the value and we are closing. So this particular example is a typical example, and I would like to remark one thing. So this list, okay, it can contain strings, right? So when we are using the tickle in VLSI, sometimes we store the outcome of any particular procedure in a list. So this for each may be used like I have shown below in the yellow box. Say set list of nets. List of nets is a list, okay? And within the rectangular bracket, we are defining get all nets. So it's an imaginary procedure which will get all the nets in a design, and we are filtering with the whichever named with clock. So if you execute within the rectangular bracket, the return value will be a list, and that is stored in the list of nets, and that you can iterate on the list by this for each command. And what operations here you are doing is up to you, because the intent of this tutorial is to make you understand and make you link your concept of the basic tickle with the tickle used in VLSI. I have put couple of such remarks so that you can be prepared, well prepared, what to use when. Typically, I personally have seen that such type of procedures are there in the standard tools, and you can filter out or list out multiple things. Okay, it may be nets or maybe something else, and you can get that out in a data structure of list. Okay, so in the next episode we will cover all the data structure, but for ease purpose you can just now you can understand that list is a list of strings. Okay, so let's move on to the next example. So here what we do, start our script, and here we are using a function called glob. So glob star.tickle. So what glob does, in the present directory where we are executing the tickle, right, this glob will find out the tickle files and it will return all the names of those tickle files as a return value. We are using the triangular bracket to execute this particular procedure, and the return value we are storing in the list called tickle files. Here we are iterating on the particular list for each file name of the list tickle files. We are printing one file name at a time, and we are closing the body of the for each. So this will print out all the tickle files are listed in the present directory. So I have used your tickle, right? It could be any file. Say it may be Verilog file, maybe VHDL file, anything. When designs are there, right, there will not be a single Verilog file or a single VHDL file. There could be multiple. So I'm talking about a particular case. So design, there might be a top.v, and there could be specific sub blocks, okay, which are also defined in Verilog, right? Or the similar thing can be in a VHDL. So there, when you are inside the live shell of the tool, right, you can collect the list like this, okay, list of the Verilog files or VHDL files, and do whatever you want to do, your intent is. So here again I'll put a remark here. So this may be used to list the files and operate or source them in VLSI. So sometimes you need to source them, or there may be some procedures in which you need to include them, okay, right? So you can use this particular type of script there. So maybe 10 Verilog files are there in your design. The basic top level is the top.v, and the rest of the things are different names. So you can just iterate. I'm giving a hypothetical example here, and you can iterate on each time on them, and you can use with some particular tickle procedure that is native to the particular tool shell, right? You can just source them one by one inside this. Okay, I'll stop here on this particular example, and similar way, or you may find other utility, but this is a very good example which you may encounter in actual VLSI. So I'll move on to the next slide. So we start our script here, and here what I am doing, I am making a list of colors, and then making list of foods and their map. If you see, so apple, the previous one is red, the orange, yellow banana, like green lime, blue berry, purple grape. Okay, so these are map. And I make a third list with the status. So okay, bad, okay, bad, bad. So this you can see, when I relate them, it becomes a lookup table. The intent of this particular example is too familiar how you can use a lookup table. You may need some time. So that's how here we start our Foreach loop and we call ABC. Then from list of colors and we put CBA. And after 300 we update. So this way we can use our list of, here we can use the three list separately and we can use them as a lookup table. Okay. So here in this particular slide we will be talking about switch case, and here it goes. We begin the script with hashbang 9 and then we set the number of age. So this is a variable is 3. Setting the value here and switch here as per the value of this number of age. And the cases are 0, there is nothing. For 1, there is nothing. For 2, there is nothing. For 3, it will execute the code that is within the curly bracket. Okay, so it will put, this is a triangle. So we know that a triangle has 3 sides or edges, right? And 4 is, this is a quadrilateral. 5, this is pentagon. Okay, and default unknown polygon. So if anything else is given, it will go to the default condition and print unknown polygon. We close it here. So this is the example of switch case. You can try it at your end. So we are done with this particular example. Let's move on to the next one. Procedure. So guys, before beginning anything in this slide, I'd like to emphasize that procedure is the very most important thing in VLSI, because writing a procedure you must know, because sometime you may have to write your custom procedures for some specific purpose in VLSI, and you also have to use the APIs, right, which are procedures defined by the tool vendor, and for their operation, their inputs and outputs, you have to make yourself familiar. So let's begin this chapter. So here we are starting our script with the hashbang line and we are writing a procedure. How I write a procedure? The proc command comes at first, then the name of the proc, and then within the curly bracket I put the arguments. Here I have used 2 arguments, A and B, and then we begin. So here what will happen? It will return what it will return, because in the rectangular bracket I am executing another procedure, expr. If you remember, we have expr earlier also encountered. So expr, what it will do, it will add, I am doing addition of $A and $B, and that addition will be returned. Okay, so this is a typical return command of a procedure, and I close here. So it's a very simple procedure with a return value and the 2 arguments. Here it takes 2 scalar, add them and return a scalar value. But in real time, in VLSI, the procedures may have scalar, may have list at some other type of data structure. And now how we use it. This is the most important part. So you set sum, and within the rectangular bracket, we use add, the procedure that we have defined just now, with the 2 arguments 5 and 8. So we will be adding 5 and 8. And then we echo the value or print the value, $sum. Okay, so this way you will be using the procedures. Similarly, like here we have defined the custom procedure, right? You may write your custom procedures in VLSI, and you have to also use whatever procedures defined by the tool vendor. So this way you have to execute them within the triangular bracket, and then as per the return type, okay, whatever it is, a scalar or a list or whatever, you have to store it in some other variable or use it. Or there could be a case you are piping through it. So there could be multiple such triangular brackets. The innermost bracket will execute first and then the next one, and you will come outside one by one by executing. So this could also happen. So here the next example, what we are seeing here, we are exemplifying one procedure which do not have any return value. It will just execute and done. So what we will name is separator, and we don't have any arguments here. So it will print a separator here, okay, in the screen, and it will done. So how we call this particular procedure, right? We just call it with its name and then we put a semicolon. We are done here. So these are 2 types of procedures which generally we can use in Tickle. One has a return type and another one is just executing something. So you try it at your end and you do experiment, okay? And don't forget to make some comments, okay? So guys, let's move on to the next slide. Scope of a variable. It's very important because when we have a long script and there we are using variables, we must know how we access the global and the local variables. This slide is for that. So here we start our script with the hashbang command, and then we set A with 2, B with 3 and C with 4. And then we do a printing value here, initial whatever value we have assigned to them, $A, $B, $C. Now we write a procedure var underscore scope. Inside that, what we do, we use the keyword global A. So whatever value inside this procedure we are doing with A, it will be linked to the initial A that we have defined in the second line. And here we set A with 20. So this value A will be set global A, that initially which was defined with 2, now it will become 20. And here another way is set : B. That means in the main scope, the B that initially was defined with value 3, now it will become 30. And set C equal to set C with 100. Okay, so it's a local C, and we close it here. And then after we execute the var scope, and then again we print the value A, B and C. Now when we execute this at our terminal, right, what we get is that the initial value is 2, 3, 4, and in the next one we get 20, 30 and 4. So you can see that although you have written set C with 100, it remains local to that, because to access a global one, either you use global keyword or you use double colon. Okay, double colon then the variable name. So this is the concept of local and global in Tickle. Okay, so we are done with this particular section, and let's move on to the next one, upvar. So this is a concept that I'll be discussing. The upvar command ties, that is makes an alias, the name of a variable in a current scope, to a variable in a different scope. So it's similar to like pass by reference. Okay, this is commonly used in a simulate pass by reference to proc. So let's see an example to understand it better. Here we start our script, and here now we write a procedure called set positive. So it will make a value of a variable positive. So we may have plus value or minus value, right? Plus value is already positive, but if it comes with the minus value, it will be changed. Okay, so there are two things we have written in the first set of curly brackets. I'll explain them slowly, okay, so you understand. Now what we are doing, the first variable, okay, upvar $variable with myvar. Okay, so there are two variable arguments coming, right? The first one, okay, whatever we are creating an alias of the actual variable that has been passed as an argument. So we are making a reference here. If $value less than 0, okay, what we do, we set myvar with expression, and within the second, that is the curly bracket, minus $value. So we get a positive value here. Okay, else set myvar with $value. And we close and return. Here we are just returning 1, because here not we are returning any value, but we are doing the calling by reference or using by reference. Okay, so here I close the proc. So in this proc, what I am doing is that we accept the variable and its value. Okay, the variable itself is accessed by reference using the upvar, and then accordingly we make the change. So now is the time to use this particular procedure. And we use set positive x and the value is 5, okay, and set positive y with minus 15. Then we print the values to our screen. Now let's see what happens. So when we execute the entire script, the output comes as x 5 and y 15. So you can see here we are using call by reference thing, and the original variable is changed. The value stored in the original variable is changed. This is the purpose of the upvar. You can use it. Okay, I think we are done with this particular section.
Hey guys, welcome to the 11th episode of Q&A. We are having a very important Q&A covered in today's episode regarding a very basic but very important application of Tickle Foreach Loop. Viewer Akshay Patharkar has asked in the second episode of Tickle in VLSI series, Sir, in last example of for each, you created 3 lists. Is there any purpose of 3 different lists? I have hinted in the episode that more than one list can be grouped together to use them like a lookup table with the help of the Foreach Loop. So, in today's episode, we will zoom into this particular situation. Stay tuned till the end of this episode to know how to do the lookup table using the Foreach Loop.
Hey guys, we are in our computer screen, and this question is asked by Akshay, which we are discussing today. He has asked this on the second episode in Tickle in VLSI, where we have discussed basics, then conditions, loops, switch and procedure. And the question is specifically for this particular code block. Here you can see the code block on which we will be doing some experiments. So without any further delay, let's begin.
we are revisiting the original code. I have kept this slide for those who have forgotten the thing, or if there is a new person who is watching this video at the first time and not seen the Tickle series, this will help that person to understand this particular code. Here goes our code, and here in this block will be our output. So our code starts with the #bang user bin tcl-sh. Next, we have the first list. The first list is a list of colors, like we have 6 colors here: red, orange, yellow, green, blue, purple. Next, we have the list of foods, that is apple, orange, banana, lime, berry and grape. 6 fruits are there. Now there is a third list, which is the status, that is okay, bad, okay, bad, bad. You can see each of them contains 6 elements in each of the list. Now I am invoking a Foreach loop where I am pulling out 3 elements at a time. So this was the original code, and I am operating this on the list of colors. And here puts command, that is a print command in Tickle, and I am printing 3 different elements, C, B and A, and after 300 time units it will update. So after add some delay on the echoing of the value on screen. And here we close the for each loop. So this was the original code. Now you can see there are 3 lists, and I have hinted that they can be combined together, but I have not shown any example that time. It was a task that you can do at your end. For a long time this has been untouched, and that's why I am making this code experiment here, so that you can understand what I wanted to mean. So the output will come as yellow, orange and red, first one. And the second one is purple, blue, green. So the entire list is exhausted here. Now we are done with this particular slide, so let's move on. So we are here in the code experiment 1. Here goes our code, and here comes our output. These are 2 placeholders. Our code begins with #bang user bin tcl-sh. The first list is list of colors, contains 6 colors. Next, list of foods, contain 6 fruits. And the third one is of status, which also contains 6 elements. Now the difference comes here. We'll be operating these 3 lists simultaneously. That is, parallelly we'll be doing the operation on 3 lists using a single for each loop. So here is our for each loop. F corresponds to the element of the list of foods, P corresponds to the element of list of colors, and S corresponds to the element of status. The 3 different lists. Now we give a puts command, and here we write here $F is usually $C and is equal to $S. This will come as meaningful once we take the output on the screen. After 300 time units, the print will be echoed and updated on the screen. So here we close. So once we execute this particular code, the first is apple is usually red and is okay. Now you can see that it has picked up 1 element from each of the lists. In the same way, if I proceed, we can see that orange is usually orange and bad. So you can see here, let me bring my mouse pointer. Here you can see red, apple and okay. Red, apple and okay. I have changed the order here in the print statement, so don't get confused. Here you can see these 3 have been picked up. Next, what is going on here? Orange, orange and bad. So orange, orange and bad has been picked up. The next one is banana, yellow and okay has been picked up. The next print command gives the lime, green and okay. The next is berry, blue and bad. So berry, blue and bad. Next comes the gray, purple and bad. So here gray, purple and bad. So you can see that this particular code block can access each list simultaneously in a single loop and not nested format. Generally, you may be familiar with a nested format where we first iterate on a loop and then inside we iterate on a second loop. No, this is not a nested format. This is a parallel format. That means we are operating parallelly on each of the list using a single for each loop. So this was the hint that I have given. We are done with this particular slide, so let's move on to the second code experiment. Here we are in the slide of the code experiment 2. Here goes our code and here goes our output. So these are the 2 placeholders. Start our code with #bang bin tcl-sh. The list is the list of colors. We have here 6 elements. Next, I have made a change here. The first 6 elements are okay, the same as the previous one for the list of foods. I have added 6 more elements. Why? You will come to know when I am showing the code. Now, here we are doing an experiment of combination of the previous 2 cases. So here the for each loop, we have for each A and B from list of foods and C from list of color. So in the first code, that is the very basic code on which the question has been arised, here I have picked up T elements from one single list. And now here you can see, let me bring my mouse pointer. Here you can see that I have picked 2 elements from list of foods. So that's why I have doubled. Otherwise this would exhaust faster than this, because here we are picking 2 elements at a time. So I have doubled the count here. Otherwise blank will come. And here what I have done, I have picked up 2 elements from this particular list, then 1 element from this particular list, and then I give a print command where A and B are fruits and C is a color. So obviously from here fruits will be picked up and here the color is picked up. So after 300 time units, we will update the print on the screen. So here I close it and let us see how the output comes. Here you can see the first output has come where apple and orange are fruits. So first 2, apple and orange, have been picked up, and 1 single element from this second list of colors, that is red. So this red is a color. In case we have created a table like there are 2 corresponds to 1, right? So 2:1 mapping, even we can do that. Here it is, there is no relation between this and this list, but we can create 2 lists where there is a relation and we can pick up simultaneously and they will be mapped to the first element. Again the next 2 and they will be mapped to the second. That is what we are getting here. Banana and lime are fruit and orange is a color. So banana and lime are picked up and orange is picked up. So 2 from here and 1 from here. The same way we print all the element in when we exhaust the for each loop. So you can see that pear has been picked up from the list of foods and a single element have been picked up from the list of colors. And one more thing, this is not nested. What we are doing here is we are doing it parallelly on the list. So we are done with the code experiment 2. I think you folks have understood how you can combine and do some experiment with the different tickle commands. We are done with this particular slide. Let's move on. Hey guys, welcome back to the 3rd episode of Tickle in VLSI. In today's episode, we will focus on to the area of the different data structure in Tickle. Before beginning anything, I would like to say one thing. In Tickle, there are 3 types of data structure. We'll go in deeper, and this data structure can be used efficiently case by case basis. So without any further delay, let's begin. So what are the 3 data structures that are available in Tickle? The first one is list. The second one is called associative array. The third one, which is the newest and latest, is called dictionary. So we will go one by one for them. So let's talk about the list. In this section, we will be discussing different features of list, the different command sets, different options, and various ways to manipulate a list. So let's begin. So first, we'll look how a list can be created. The first way is that you can write set my list, and within a rectangular bracket, you can type in the procedure list followed by the list elements. That is, here 3 elements are there, A, B, C. So A, B, C will make the list. In the similar fashion, but in a different way, we can create the list like that. Just write set my list. Then within double quotes, A, B and C. Each are space separated. The third option or the third way we can create, instead of using the double quotes, we can use the curly bracket here. It will create the same list. Another way is that we can use the dollar symbol when we are using the list procedure. Okay. Again, this dollar value can be used when you are using the curly bracket. So these are the ways we can create a list. In all of these 5 options, you have a direct approach of creating a list. There will be indirect approaches, which I will explore in the later part of this tutorial. So stay with me, and we are done with this section. Let's move on to the next. I was talking about the manipulations. So we can split or concat, or we can judge a length of a list. So let's begin. So in this section, I will show the code in a pink background, which is the tickle code, and the corresponding output will be shown in a black background box. Okay. So the pink box contains the code and the black box contains the output. So this convention I will follow throughout the entire slide. Okay. So let's begin the code. We have our shell declaration at the first.
Then here we can use the split procedure. Set, then we write a name of the list, and within quotes we write the path of a file. Okay, say here is starts from home and it goes up to the tickle test folder. So it's in this case it is a folder, and with respect to slash we are splitting it. So slash will be the second argument here, which you can see within the double quotes. The first argument is the path, the second argument is the slash. So it's a particular example, but the first argument there you can have different, instead of slash you can have a comma or some other kind of delimiter. So that delimiter you have to specify as the second argument for the splitting. So this will create a list and save it into the M list, and we can echo the M list here with the puts command. And once we do, it will print out the list that will contain the folders there in the hierarchy. So let's see another example. Here we are creating the list LST with the list function, and 0 to 7, these are the elements we are using here. We are just checking the echoing. Okay, it's echoing correct. And then we are using L-index. So L-index is a particular procedure here. Okay, obviously it's a keyword, but it's a procedure here, and it can actually pull out a particular value which is situated at the index. So the first argument is the list, the second argument is the index. So it will pull out the value sitting at that particular index. So here what is coming out? 3. Okay, because it's at the 3 index. Okay. So next we are using the concat procedure. So what is there? We are using first list, okay, LST, and within a rectangular bracket we are giving 8, 9, 10, and we are using the concat. Okay, so I don't need to repeat again and again. The first argument is the list, and second argument is the next element. So concatenation in general means that you are joining things. Okay, so we have split, we have seen the split, now we can see the join also. So here what we are doing, the first list was there and we are concatenating another list. So the entire list will go to a second list, okay, which is LST2. And if we echo it, you can see that 8, 9, 10 has been added in the series. Okay. The next one is append. Previous one was concatenation and this is append. So when we use the concat, right, we are saving into another list. Obviously, we can save into the same list, but since we are here, the purpose of this particular slide is that how we can manipulate. So we can also use the append command to append things at the last of the list. So here we are appending 11, 12, 13 and 14 to the LST2. And when we echo, we can see the elements have been added. So the next command, that is lset, that actually manipulates a particular index value. So here we are setting the 15th element, right, and with the value 15. And if we echo, right, we can see that it has manipulated and it has changed the value 14 with 15. Okay, we'll request you to try the code at your end to understand and play with the code so that you can understand better. Here we are again using the length procedure here to judge the length of a list, and we are storing the output of the procedure L length, which is coming out of the rectangular bracket, into len variable, and we echo the len and it is echoing that the length is 15. So this way you can do different manipulations in the list. So we have covered, split, concat, length. Okay, so all of this in this particular slide. So let's move on to the next slide. So here we will see the sorting procedure. Now we are talking of sorting. There could be different type of sorting. The types are, we can do the ASCII sorting, we can do the real number sorting, we can do the integer based sorting and dictionary based sorting. Okay, so let's see. As per our previous slide, pink box contain the code and the black box contain the output. Here this is a continuation code, so I have not shown the TCLSH line, and here we are using the previous LST2 that we have just used, and we are using the lsort and lsort procedure to sort, and with the ASCII method, so it will operate and store back into the LST2. And if we put it, what we get, so in ASCII what happens that it starts with in ASCII order. So you can see the first element 0, then 1, then 1 0, then 1 1. So anything related to 1 comes and finishes first, then it is 2 3 4 5 6 and on. So it is the ASCII sorting. So we are again using the lsort, and this time we are using the integer procedure, okay, the integer method for sorting. So here if we echo it, and what will happen that it will sort the list as per the integer. and we can see it is sorting it in an incremental way. So it's starting from 0 and it's stopping at 15 with the integer method of sorting. So in case we want to sort it in a decreasing way, we have to add a dash decreasing switch here. So to the else sort procedure, and that will do it. And if we use the integer and the decreasing together, this is the output that comes. So it starts from the higher number and goes to the lower number. These are the things that you may need when you are doing the actual manipulation for the tickle code for your VLSI tool. There, if you came across something which you need to sort, if it is a number, you can sort it as a number. If it is a text, you can, based on ASCII, you can sort it. So then you can iterate the list and use it as per your need. So let's see the next one. Here we are using the dictionary sorting, using the dictionary switch here with the else sort procedure, and let's see what happens. If we do this and print out the LST2, it does the dictionary sorting in this case. Okay, it's also similar to that integer sorting what we have seen. Let's go to the next one. Here we are defining a real number list with the name RLST, okay, and the elements are declared in a double quoted way with the space separated value, okay, all real numbers. We just here we have, for sorting this, we have to use the dash real switch, okay, with the else sort procedure and give it, and we are saving it back into the original list, and then we are echoing. So we can see that the thing has the real list has been sorted as per the real number, and the smallest real number has come first, then the bigger one, then the bigger one. This is only you can understand value by the value. So it goes on, and the highest real number is at the last. Now if we want to do the reverse sorting, we have to add a dash decreasing switch here. So else sort, then real, then decreasing, then the list name, okay, with the dollar. And if we echo it, what will happen? It will start from the highest real number and it will go down to the lowest real number. So this is a way of dealing with the different kind of sorting in a list. At the beginning I said we will see how we are manipulating a list. So this is how we are manipulating a list with sort. So this section is done. Let's move on to the next section. Iterating over a list. Pink box, code, black box, the output. Okay, so we start here with our code, and here we setting x, list x with the elements ABC, and we are just echoing here. And here in this particular put statement, I have used the lindex command within the triangular bracket directly in the ports. It can also be done. Okay, and we can see here that it gives the C value. Try this at your end and you will get the results. Okay, you can see that the 2th element, that is 3 elements are here. The first one is 0th, then the 1, then 2. So at that 2 position, right, the element is C. So here we are next, we set I with 0, and we are using a Foreach loop to iterate over the list. And we are using the puts command to print that J is the item number in $I in the list in X. So J is the element here, okay, $J, and the I will give the index, and we increase at the end with the INCR procedure, and we close the for each. So the magic guys here, you will see that how this operates. If we execute this, it will print out like this. First one, A is the item number at the 0th position of X, B is the 1 position of X, and C is that the 2 position of X. Now the for each loop, it grazes through the index, and when you use the for each loop, you graze through the index and you get the corresponding value. You do not graze in a random order for a list. Okay, that is what we have learned in this particular slide. So let's move on to the next slide. Append, insert, and replace. That's all we are talking about in this particular slide. Okay, so again, we are here for the manipulation of a list. These are also the manipulation tools of a list. Here in the pink box, we are using the code. Black, we are using the output. Here is our first shell command, that the first line of the code. And we here write a test list with the 3 elements ABC, accessing the elements by index. Okay, so we are using the lindex command, and we are using the test list and the 0. So it will give output A. Okay. And it's the magic. Say we don't know how long a list is, and yet we have to print the last element of the list. We can use end keyword that will give C. Next, we append using the append D, test list D, the entry to the list will be from the right hand side. Okay, so this D will go after C, and we echo it and we see yes, it is coming at the last. Here now the question is how we can make the entry from the beginning, that is from the left hand side. So for that we have to use the L-insert procedure, and we have to give 0 as the position where we are pushing that particular element. Okay, so we echo it and we see that E has come at the beginning and the rest of the elements are after that. So for entry of an element from the right hand side we have to use L-append. For entry from the left hand side we have to use the L-insert. I have shown you the both. Still you can play this L-insert, okay, in multiple ways. So you can do that at your end. Replace a single element, okay. So we can use the L-replace procedure, okay, in the test list. You can see in the rectangular bracket here, and the first argument is the $test list is the list, and then we give the range from 2 to 2. So it will start at 2 and end at 2, and means it will stay at 2 and it will replace with K. If we echo it, what will happen? That B is now replaced with K, okay, and let's see another one. So here L, we are using the L replace, and we are replacing the last element. So end. So it will start at end and it will end at end. So the range is end to end, means one particular position. So we are using the L replace and we are replacing the last element with I. And we echo it and we can see that D has been now replaced with I. So these are a couple of another ways you can manipulate or play with a list. Okay. So data structures, here I would like to give a pause and say something, that data structure a very important element when you are dealing with huge amount of data. The manipulation are not just only that you are manipulating it to know it, but in actual time you will need these manipulations, okay, for a particular target that can be judged by you. Okay, so here we are done with the particular section. Let's move on to the next. The list of list operations. In this section, I'm going to discuss the nested list. So nesting, I think whoever learned C, they are much familiar with the concept nesting. Means one particular thing is instantiated inside similar particular structure. So that is called nesting. So list is a nested structure of data structure. So we'll talk about this in this particular section. So in the pink box, the code goes, and black, the output will come. So let's begin our code with the shell, and then here we use the list of list. So how we are defining? We are using the list procedure, and then first two elements are A, B, and then the third element is itself a list, that it's whose elements are C, D, E. Fourth element is again the list of list. The first element is F itself, and the second element is again a list whose elements are G and H. So it may take some time to understand this, but this is how we can define a list of list. And when we print out this particular list, we get these as an output. So we have A, B, third one is C, D, E. The fourth one is a list of list where the first element F and the second element is another list whose elements are G and H. So this is the example of a list of a list. We can also use the split command here and you can see the output, how it goes. So when you output it, the backslash command thing come, okay? So this backslash means that the curly brackets are not elements, they are the list separators, right? That means whatever we are writing for actual. So that backslash denotes it as a special character, not as a normal character. You can understand how the list is now treated. Again here, we can concatenate, okay, on a list here, list of list operations. So we concatenate the A, B, then the list is C, D, E, then the third list is F, G, H. Now here I would like to pause and give a focus to your mind that we are here doing the concatenation, means we are concatenating or joining three lists. It will end up as a list. And what it will be? So will it be a list of list or it will be a simple list? Let's see by the output. So when it concatenated, we can see A, B remain as the two elements, then the third list is concatenated and flattened. So the next elements become C, D, E and F. Only the third one, which is a list of list, the first element is flattened but not the second element. So what the concatenation operator has done, that it has flattened the first level of list, not the second level or the third level. If any list was there, list of list operation goes a third level of hierarchy, so only the first level will be flattened. Okay, rest of the things will remain as is. So this has become a list of a list but not consisting of the three. So here is the difference. How you create a list of list and when you concatenate three lists, two things become different. The first thing is shown in the first example of this slide, and the latest one which I am right now talking about is the concatenation of different lists or different list of lists. Okay, so let's move on to the next one. So here we are using append command, that is to append. What we are appending here? I, J, K, L and M. So this is a single element. Okay, and after appending it becomes like this. It becomes a third element. So to the flattened list we are adding another element here by the append. And here again you are using the insert command, okay, at position 3 with the single element 1 to 3, and it output becomes, so you can see that we have insertion, okay, not a replacement. We have done our insertion and it has become A, B, C, then 1, 2, 3, then D, E, F. Okay, so this is the difference of insertion and replacement. So what you understand from this is that you can insert or replace, but they are two separate operations. Here we have shown the insert operation. And now we are showing the replace operation with the L replace. And here we are using the range 3 to 5. And what elements we will be using? We are using 2 elements. So we are replacing 3 elements by 2 elements. Okay. And once we echo it, it replaces 3 elements by 2 elements. You can have practicing using this code at your end, and please don't forget to comment. Okay. So we are done for this section and we'll be moving to the next one. So another set of list operations. Let's see. Here will be our code and here will be our output. So code begins here, and we can create a list of list in the similar fashion here that we are done already, but here we are using the triangular brackets. So you can see if we read from left, right, the first 3 elements are A, B, C, then the next element is a list whose elements are K, L, M, then P, Q are the normal elements, and then again the next element is a list of list which is RW. So if we echo it, it will print out the list elements like this. Okay. And puts again we are using the third index. Now you want to reconfirm that the third position of this list is what? Okay, it will put out another list. So that is KLM. So the third element is KLM, confirmed. So next we print out the 6th element. Okay, and it prints RW. Okay, that is the last one. Okay. And now we are doing another level of manipulation. That is, we are using piped structure of commands here in TCL using 2 level of rectangular bracket. Here what we are doing is L index, and then first inner one will be executed. The first inner triangular bracket will be executed, and then the output goes to the outer one, and like that. So the innermost will first. So L index J list 6, it is the 6th element. And once you get it's a list of list. Okay, so the first element of that particular list of list will be printed. So what we get here when we echo this, it's a W. So there are 2 elements 0 and 1, and we have printed out the 1. So that is W. So guys, this is the examples of a list and accessing them. So we are done with this section. Let's move on to the next one. Searching element in a list. So here what we'll do, black will be the output and pink is the code. So let's begin our code here. Our shell goes here and searching inside an element. So here we use the else search. So we have a list. We don't know the content of the list, and we want to search whether a particular element is present in that particular list. So for that we are using the else search procedure. And in the triangular bracket you can see that else search, and we use the list, test list, and then A. So this is for your educational purpose. This is not going to run right now. And positive or 0 return value for an existing element. So if it returns 0 or a positive number, that means this particular element A does exist for the test list. Okay. A negative return value, say -1 or something other for a non-existing element, will show by an example down below. We create a list with the fruits, apple, app, ban, banana, c, carrot. Okay, so this is a list which contain names. Okay, and we use the else search procedure inside for the LST, and we use the app element. Okay, so we know that app exists there, so the return value comes as 1. Okay, this is a tried and tested code, so I'm using the outputs from there. You can try it at your end. And if we search else search that AP, by looking at this particular list LST, is there any AP element? No. Output comes as the -1. So the positive value or 0 value gives a confirm that there is particular element exists in the list, and a negative value will say it doesn't exist in the list. So this is a searching inside a list. So we are done with this section. Let's move on to the next one. Here we'll talk about the associative array. Associative array is another data structure. By array, if you recall that what you have learned array in C language, right? That is very similar to the list. But associative array is a kind of mapping. It is also called a hash table in some data structures, or hash in some data structure. So associative array is a kind of hash table which uses the key value mapping pairs. Okay, so in this section we'll talk about the associative array. As usual, the pink box will contain the code, black one will the output. Let's begin our code. Here we are using the set command to create the associative array. Okay, so how we do? We write set, then the array name, then the index within the first bracket. Okay, and then we use the value. So here the index is rows and the value is red. So this way we keep on defining set color sky and the value is blue. Simply the middle is the key and the value is gold. Leaves is a key and the color is and the value is green. Blackboard is the key, the value is black. And now how we can access the array elements? Okay, for that we are using the Foreach loop. Foreach, then the element LE, and then we use array, then names, then color. So this will give all the index values, that is row, sky, middle, leaves and blackboard, okay, as a list. Okay, and from that list we are picking one by one, and we are directly using a rectangular bracket here for this purpose to generate the list. So array, names, then color. Okay, the keys are called names here. Okay, and we print out the $LE is the element and its value is $color. Then within first bracket is $LE. So this way we will access the array elements, the values. Okay, and then we close the bracket. Once we execute the code, the outputs will come like leaves is green, blackboard is black, rows is red, middle is gold and sky is blue. So this is the way you create the associative array and you access the elements by the key value pair, okay, using the Foreach loop. Or if you want to access one particular element and its value, then there is no need of the for each. You have to know the key name and accordingly you have to give the value. Okay, and we're done with this particular section. Let's move on to the next one. Array set and array get. These are another approach. Okay, let's see how we can use it. Here goes our code and here goes our output. We begin our code here and we are using array set command to define a associative array. Array set, and then we are writing the key and the value pair. Okay, so the key is rows, its corresponding value which is mapped to it is red. The similar way we keep on writing the other pairs. Okay, it is the same key value pair combination from the previous example, and here we are closing it with the curly bracket. So array set command can also be used to create. I have used multiple lines here, but still you can use it in a single line. There is no issue. And how we are accessing it? Again, we are using the Foreach loop. Okay, this time what we are doing? We are using the command array get. Okay, array get to generate key value pair. Okay, and which we are actually catching in the obj and call variable. Okay, you can see for each, then obj and call are written in curly bracket. Okay, it's a list. So this pair will come into the object and call, these two variables. And array get will pull out one key value pair at a time. Okay, and we echo them as previously we have echoed, and let's see the output. So it will, board is black, leaf is green, row is red, middle is gold and sky is blue. So this way we can use the array set and array get command for creation of an associative array and accessing its key value pairs. This is another way. So let's go to the next section. Checking whether an array element exists. So any key value that inside the associative array, whether it exists or not. So here goes our code, here goes our output. Run our code and we create our array like array set and we define the elements, okay, and their values. Key value pairs are defined like that. And now we are defining another list which is totally different. This list elements are defined by the list procedure and you can see different colors are there. In the first associative array there are 1, 2, 3, 4 colors and they have corresponding numerical values to them. But in the list we have only name of the colors, okay. And let's see, we'll iterate over this particular list to find which one does exist in the above mentioned associative array and which one do not. So here we use the for each and we use variable called color, which shortened it as a call, and the list lst is there. So we start it, and here we are using another procedure, catch. It is from tickle and it can catch and return value. Okay, so we are using another procedure called info-exist. So we are using to check the key value pair. So $color count, okay, and then the element $color. Okay, so it starts from the innermost one and comes to the outermost. Okay, so the info-exit operate on this and it will return a value, and that particular return value will be captured in the variable ret, which we are defining with the catch command. Okay, so if 0 equal to $ret, what will happen? Will echo it exists. So if an element exists or as a key in a particular array, the return value is 0. Else for any other values, it will echo not exist. Okay, and we close the if-else loops here, conditions here, and we close the Foreach loop here, and let's execute this code. What happens? So it first remember it is iterating over the list, okay, which we have separately done. So first it goes to red, it sees it exists and the corresponding value is 1, green exists and corresponding value is 5, yellow do not exist, purple do not exist, and white it exists and whose value is 9. So here you can see how two different set of data are there. One is a list, another is a associative array, and we are checking whether elements of the list can be present or not present in the mentioned associative array. So one remark here that we can use such kind of comparative data structure when we are iterating for a particular design for making it perfect or achieve our design goals, okay, for eradicating errors. How that we know that there are, say just for an example purpose, 10 or 20 number of nets on which we are doing something, and each net has a corresponding value, say load or slew, something like that, and which is coming as an outcome. So we are iterating, and every time we check on the 10 nets, those are defined in the list, and the values which are coming by other procedures or something that are saved in the associative array. So every time we can go and check whether that exists, and when this data structure array is created, whichever particular net has been achieved the goal is getting excluded. So this particular case scenario, it will happen that you will get only the erroneous nets and their values. So this is just a typical example where you can use it, such comparative data structure. So let's move on to the next slide. We're done with this particular slide. So here we'll see how we can convert an array into list, or we do the reverse. Okay, let's begin. Here goes our code and here goes our output. Here we are using the shell, okay, the shell command line, and then we are using array set. So we are doing the same associative array here, and we have defined with 4 key and the corresponding value pair. So we are using array get command. Okay, it will get all the keys, right? So h2l. So it will get key value pairs, sorry, not the keys, the key value pairs it will get. So that will go store in h2l. So hash table to list. So that is what I have written in a short from h2l, and we echo it. So what will happen? That it will echo blue 4, white 9, green 5 and red 1. So all the key value pairs have come into the list h2l. So let's see if we reverse this h2l, what happened. h2l is now reversed and we are using the array set command. Okay, we are using the array set, that is L2H. L2H is the target array structure, associative array structure, which will eat up the list and make it associative array h2l. So this is, we are using array set command. And then we are using the for each, because here now we will not print out, we have to see the key pair values are coming correctly. Like previous, we are using the object and color, two variable less, and we are using array get command to get L to H, and we are iterating on them and we are echoing them like this. Okay, and we are closing it. Once we execute this for each loop, right, what will happen? The key value pairs will be printed. So let's see, first one is correct and second one is also correct, third one is correct and fourth one is correct. So here we have seen the two ways that we can convert an array into a list and we can convert a list into an array. But condition is that that should be key value pair, so the number of count should be even. So one key one value, one key one value kind of stuff. The list should be even, otherwise the value will be maybe an undefined one. So I have not tried it, so you can try at your end what will happen. Okay, please don't forget to comment. We are done with this particular section, and let's move on to the next slide. Yeah, let's talk about the dictionary. Okay, this is not a dictionary that we are familiar with our English language. This is a separate thing. It's a data structure. Okay, we are talking about this in this particular section. So let's begin. So the dictionary here, let's see how we can do it. Let's know about it. In TCL 8.5, dict command has been introduced. So dict is a command procedure that creates the dictionary, and it has started from TCL version 8.5. So that's why in the beginning I was saying that dictionary is a much more latest data structure in TCL. This provides the efficient access to key value pairs. We have used the associative array as a key value pair, right? But dictionary is much more efficient and advanced. We'll see by examples later on. Okay. Dictionary is like associative array, but order of the sequence is not important. That is another feature of this dictionary. Dictionaries can be passed on to a procedure. This is another benefit. They can be passed on to a procedure. Unlike arrays, dictionaries can nest dictionaries. In the associative array, we cannot nest the one associative array inside another. Okay, list we can do that, we have seen, but not in associative array. Okay, not in associative array, but dictionaries come up with that feature. So that limitation of associative array has been overcome in dictionary. Hence, dictionary help you to build complicated data structures such as hierarchical databases. So once you can nest one dictionary inside another, you can build a hierarchical data structure. Sometimes that might be necessary. Okay. You can also combine dictionaries with other TCL data structures. So dictionary can mingle with other data structure in TCL. So let's begin. We are here showing an example of a dictionary. So here there is only the code. So here pink box is there. We begin with TCL shell. Okay. And here, this is how we create a dictionary. At the first, we use the keyword set, then the dictionary name is ft, and within rectangular bracket, we are using the dict procedure, okay, and the create command, okay. So dict create to create the dictionary. Here we are using the key value pair of different types of file extension and their type or the name. So .txt is the key and the value is text. .jpg is image. .zip is a zip archive. .doc is a document. So here we have used key value, 4 key value pairs, okay, to create a dictionary. And this way we can use dict create, okay, this procedure to create a dictionary. And adding, if we want to add, we have done this, but if we want to add, right, we can add more key value pairs, okay. So dict set ft, this will add another key value pair, that is .mp3 is music, okay. So these are key and value. So one thing here, because this is, the order is not important, right, this is not getting appended, it is getting just included rather than, okay. So we add another set of key value pairs, dict set, then ft is the name of the dictionary, okay, dict set is the command, and we are using .avi as a video. So lot of file types and their names, okay, extension and their names. So we are using dict for loop, for it is a special loop for iterating over the key value pairs in a dictionary. So dict for can be used in dictionaries. It cannot be used in any other data structure in TCL, okay. So let's see how we can do it. Dict for, then we give the key value pair. So it's a list. ext I have shortened for the extension, and desc is the description. So ext and desc is the two different variables of the list for each key value pair coming from the ft. So here dict for is used, and we are accessing key value pairs of the dictionary ft. And here, once we get it, we will echo the description and the extension. So the value is printed first and the extension is printed next. Okay. This is one way. Another way is that we can use the Foreach loop, the general Foreach loop, okay, for accessing this particular data structure. That is not a limitation. We can use the foreach command, and then we use the list, which contains two variables, ext and esc, and then we use the $ft, okay. In a similar fashion, we are printing out the same line and we are closing. So these are the two ways of accessing the dictionary elements one by one, and we have seen how we create a dictionary. So that's all with this particular slide. Let's see the what is the output, okay. Once we execute this code, what happens here? At first we get text is .txt, image is JPEG, zip archive is zip, document is doc, music is mp3, video is AVI. So all this comes. This came from the first set of data, came from the dict4, and next we are using the general Foreach loop. So that gives the same output. So either of them you can use for accessing the data structure. Let's move on to the next slide. We are checking a dict exist. So this will check any particular key, it does exist inside a particular dictionary or not. So here our code will be here. We start our code by the shell, okay, the TCL shell. This is the continuation of previous code, and we set a list, okay, we create a list, okay. So this list contains of couple of extensions. So .txt, .og is og verbs, right? So .rar and .doc. So it contains 4 elements, okay. Let's now iterate over this list and see whether the elements of list, whether they exist in the declared dictionary, okay. So for each $element of LST, okay, we are iterating over the list, and we will be checking on the dictionary, checking for LA, okay. So for checking the existence of a dictionary element, right, we use dict exist. So we are directly using it inside the if with the rectangular bracket where it will return the value. If the value is a positive one, right, here what it will exist, okay. So dict exist $ft, $ft is the dictionary name, and the $le is the element that we are checking whether it exists as a key, and we say it exists if the outcome is positive of the dict exist. Else we say this particular key do not exist, and we close it, and we close the Foreach loop here. So this is the way we can iterate over a list which contains some keys which are random, and we check whether all these random keys, whether any of them exist as a particular key of our dictionary. So the outcome will be like this. First one, txt exist, og not exist, rar not exist, .doc exist. So we have clearly checked these random elements whether they exist inside a dictionary or not using the example shown below. So it's output. So you're done with this particular section. You can have a try and don't forget to comment, okay. Building a complex data structure, okay. So dictionary is meant for complex data structure. Let's see how we can do it. We start our example here. Here goes our code. First line is the shell. So creation of a complex data structure. So it will create an employee database. There is a 1:many mapping using dictionary. So one employee, and it will have many data around it. So let's see how we are going to do it. Data for one employee. Dict set employee, then we give the employee number, okay. Dict set employee info. Employee info is the dictionary name, okay. Key is 12345-A, the first key. Code name is Joe. And then we write the same thing, and we write surname as Moy, and then we write the street as 147 short street, okay. So this way we define the city, this way we define the phone number. Here we are done with the first employee. So the data structure, you can see for one particular key how many hierarchy we are going. For that we are, for particular key 12345A employee code, we are saving that is forename, surname, street, city and phone. So there is another level down, okay. So forename is mapped with the value Joe, surname is Moy, and street is short street, okay, like that. And we are making a database for another employee here. In the same way, we are set employee info, and what we are doing, we are giving a particular key here, which is 98372-J, and the forenames is Annie. Okay, so like that, second we define the surname, we define the street, we define the city, and we define the phone. So here another database of an employee is created. So there are two employees in the database, which is a complex data structure, and let's see. This is how we have defined. So in this particular slide, we are discussing the access of the dictionary data structure that we have just created. Okay, here goes our code. First line is the shell. This is a continuation of the previous code, and we print the employee info here. We set I with 0, then we put in this particular print command, we are directly using the dict size to check the dictionary size, how many keys are present, okay, or how many actual pairs are existing with the dict size directly inside the rectangular bracket, and we are printing directly inside the puts, okay. And then we are using the dict for, then we are using a short list of two variables, that is id and info, okay. We are using dict for, and then we are going to the employee info, and we here put command to print out the id, okay. We are using the dict with info, this particular function or procedure, okay. Puts name, forenames, and the surname. We are accessing dict with info for this particular employee ID. So info is the value. So this value is also hierarchical database, another kind of hash table. So from there we will access. So dict with will give it will help to penetrate inside that particular data structure and give us the outcome. So again, we are putting address, then $street and the city. So it will print out the street and the city associated with the particular employee name. So forename and surname. So these are, we are using directly the keywords here, and we are using with the dollar value, right? So it's a kind of very easy to operate in the dictionary, right? So, and the telephone is the $phone. So we're closing here. So for each info, that means for each employee, you are printing out this all the key values pairs, okay, and we can directly access them with a $sign. Beauty of this particular dictionary. And here we closing the first curly bracket, which is from the for, dict for, okay. Once we execute this, it will give the output like this. It will first print out there are two employees, that is we have checked how many elements are there or how many key value pairs are there in the dictionary, and then for the first one it will print out the name, address, telephone, etc. okay. And the second employee, it will also print out the name, address, and telephone. So this way we can use the dictionary to iterate over the dictionary elements. This is the first approach. So let's move on to the next one. This is the approach 2, how we can use it. So here we start with our shell, and it is a continuation of a previous code, okay. So let's go. It is another direct way to iterate and pick out names, okay. Given a dictionary key, the first argument, and the value as the second argument. This dict get will retrieve the value for that particular key. So this is just description I have written in the code as a comment, and here I am explaining it to you. We use Foreach Loop, and then we use the ID. We use the dict keys command to access the keys of the dictionary, right, employee info. Then what we write, the set name, then we use the dict get procedure, and then we use the employee info, then ID, then forename. So this way what we do, we first access the employee info dictionary, then the ID means the next key, and then the next key is written as forenames, okay. Here is the surname. So we are getting outcome of this thing as in the two different variables, name and surname, okay, as the forename and the surname, right? And we are doing a puts command. So this way, it is a more direct approach, direct hierarchical approach we are using here to go up to a particular 2 level or more than 2 level down key and its corresponding value, okay. And here we are closing the Foreach loop, and if we execute this, this will come like this. The first, it will print the first name and surname pair, hello, and next is the second one. So this is another approach of accessing the dictionary elements. So guys, this might take some time to get familiar with these things for you, because you to try at your end and create, and don't forget to comment, okay. Welcome back to the 5th episode of TCL in VLSI. And in this episode, we are going to discuss about various string operations in TCL, regular expressions in TCL, regular expression find and replace method, regular expression wildcard matching, regular expression group matching and match status, regular expression replace and match count, file input output in TCL, named code block, inbuilt mathematical commands, and TCLSH commands. So without any further delay, let's begin this episode. The first chapter here is the string operations. This is a very short and sweet description of the string operations. So let's see. In pink, the tickle code will be displayed, and in this black box, the output will be displayed. So we start our tickle script here with the user bin tcl-sh path. The first we set a string as set, then statement, then within double quotes, we start with the space, then fan is a student. And then we give a space and close the double quotes. So this is the string in consideration or string under test. So we just check it here, echo it here, and we see, okay, it's coming as. So you can see when we echo it at the beginning, their space is already printed. So what do we do to cut out the extra space? We use operator. We use the set statement, then again we write string, then trim, then again use the dollar statement. So what this rightmost rectangular bracket operator does, that it trims the space. And then we echo statement. So now you can see the left space has been removed. The right space is also removed, but we cannot see in the display. So this is how we can remove the initial and the ending space of a string. Okay. So here another command is that we directly using puts command, so that directly we echo the output. So use string, then length of the state, then the string name is length. So it will count the length of the statement. And here we can see 16. So I'll suggest you to count it and match it. And obviously you are going to try this code at your end. Don't forget to do comment and like. So the next one is that we use string, then index, then dollar statement, then 4. So we'll be checking the fourth index of the string. Okay, what is this? It is I. Okay, so this is how we see the indexed element. Okay, so the next one is then string, then index, then the string value is dollar statement comes, and then end. End means the last index. So it's T. Okay. So then we try another command. String first is, then the statement. What it does is giving 4. Okay. So again we check last is statement. Okay. Is 4. So it is the giving the index of the substring is starting at which index. If we just for trial we reverse it, interchange the place, what does it give? Okay, statement and is, it will give -1. Okay, so the whole statement cannot be find inside is. Then we are using the range operator here over the particular string dollar statement. So we use in the rectangular bracket, we do string, then range, then dollar statement, then port, then to end. So we'll use the range operator starting from 4th index to the end index. Let's see what it gives. So is a student. So it gives you the section which starts at the 4th index and stops at the last index. So is a student, it is giving. This is the range operator. Now we are using the replace operator. Then we write string, then replace, dollar statement, then from 9 to end with, we are replacing with professor. Okay. So the string is replaced now, and you can see fan is a professor now. Okay. So this is how the replacement inside a string can be done. Then we are doing a match. Okay. String, then match, then within double quotes we have start, then student, then dollar statement. So this is a matching. Whether there is a matching or not, the response is what means yes, this word is a substring of the main string. So these are the couple of string operations in Tickle. So we are done with this section. Let's move to the next section. Regular expressions. So regular expression is very common in all of the high level scripting languages. Even shell we have, in Perl we have, in Tickle we have. So this helps for many advanced users, especially say when you are using in VLSI, you might need to use a regular expression to match maybe a net name or maybe a cell name or cell types or net types. Okay, so there you may require to match with the regular expressions. So these can be very useful. So be careful when you are learning the regular expression and using it. So regular expressions can be expressed in just few rules. The rules are: caret matches the beginning of a string, dollar matches the end of a string, dot matches any single character, star matches any count of the previous character. Okay, plus matches any count but at least one of the previous character. Rectangular bracket matches any character or a set of characters. Caret, when used inside the rectangular bracket, matches any character, not a member of the set of the characters following the caret. first bracket groups a set of characters into a subspecification. So this is used for group matching. So these are the few rules for regular expressions in Tickle. We are done with this particular slide. Let's move on to the next one. Regular expression, find and replace. So here our code will be in the pink box while the output will be in the black box. We start with the Tickle path. Then we set one string my_str, set my string within quotes is a quick brown fox jumped over a brown lazy dog. So this is a well-known phrase. So I'm using it here. Used for pattern matching, regular expression. So if then within rectangular bracket, we use the regexp command and then with dash no case. Okay, so we are case insensitively we are matching brown and then my_str. So suppose we are here, we have defined the string at beginning, but it may happen that we do not know what string we are matching. So that's why we have used the no case here. And let's see if this particular brown word is matched, okay, to the any of the substring. So the return will be 1. In that case, the if will be true. And we will print the string and puts is there. So the output comes like that. Match found in a quick brown fox jumped over a brown lazy dog and replacing. So replacing is the next one, the next command. Okay, let's see the command. So we use the regsub command for substitution. Regsub, then with no case, then all. Okay, all means all the instances, and no case I have already explained what is that. So brown, then my_str, then the next, the string that we are using for replacement is replaced in upper caps, and then again my_str. So you can see there are two regular expression functions or procedures are here, right? One is the regexp, which is used for matching. Okay, it gives a binary output, and regsub is the regular expression matching and substitution. Okay, so here another thing is that in sequence we give first the word we need to find and then the string in which I need to find, and then we give the word which is that which we use for replacement, and we give the target string. So here we have used the same string so that the same string will be replaced. And now we echo the same string here. We close it. As we execute this regsub, what we get now, it is quick replaced fox jumped over a replaced lazy dog. Okay, so brown is used twice in the whole string and it has replaced all of them. So that is the purpose, so is that all. So here I'd like to request you to try out, go to the manual page and try out any other options associated with the regsub. Okay, so here we are done with this section. Let's move on to the next slide. Regex wildcard matching. Okay, so code will be in this pink box while the output will be shown in the black box. Here goes our TCLSH. We use the string set race a quick brown fox jumped over a brown lazy dog. So here we have just intentionally changed this brown word to brown. Okay, so let's see. We use for each, then element, then $res. So now res will be treated as a list. Okay, and here it will iterate each element of the list and we will check here. So if regexp b dot star n. Okay, so b followed by any character multiple times, that is star. I have just explained star now, and this will finish with n. So anything that starts with b and ends with n, and in between any character any number of times. Okay, in $element. Okay, if it is true, it is matched, it will be printed. So here we echo it, we close it and we run it. So here once we run this code, we get brown and brown. Okay, so here because b and n are the beginning and the end, okay, the two characters, and in between we have done a regular expression matching and it could be anything. Okay, so that's why we get the two words. Now you can understand why we intentionally change brown to brown for the second particular position. So we are done with this particular section and let's move on to the next one. Group matching and status. So first our code will be in pink box while our output will be in the black one. Okay, so here goes our TCLSH, and here we set sample where there is a will, there is a way. This is also a known phrase. So match the first substring with lower letters only. Okay, we use set result. Okay, then we use the procedure regexp, then we use within curly bracket, right, then within that rectangular bracket A to Z, that is the range, and plus means at least once or more. then sample, then it goes to match. Okay. So here we will be getting the outputs in two forms. One, the result, in that the match status, okay, which is the outcome of the rectangular bracket, that flag will be printed, and the match string will go to the match variable. Okay. So let's see. And the next is set result regexp. In the similar way, we have used here within the curly brackets, we have used grouping, okay, using the first bracket, okay, or the brace. The range we have given capital A to capital Z, and then capital A to small z, okay, then plus. And then in the next grouping, we have used small a to small z, okay, and then plus. So this will be two groups that will be matched inside the string. And then the source string in which we trying to is the sample, and then we get match, okay, then we get sub1 and sub2. So this sub1 and sub2 will catch the output of these match groups. Okay, so if you can see that in the two operation, the regexp is common, but how we are using it is a bit different. Okay. And here also we will match the match status echo, and then match first string and the second string, two substring. So here goes our first output. The first puts in this, there are only two puts command here. The first will give the match status 1, because the status gives binary output, and the match string is here. So there it could be here. I'll try. Okay. So here the next puts command gives match status is 1 and match string where there, okay, is a first string. Okay. Here within the angular brackets, what I have done is that where there, these are the output. So there I have captured the outputs. Okay. So in the output, you see that the triangular bracket consists of the outputs. The second substring is where. Okay. The first string is sub1 is where, and the second substring is there. Okay. So these are, and the match string is where there. It is the entire one. Okay. The entire matched one result. Okay. So I would suggest you to try it out at your end. Use different kind of string structures and matching regular expressions. Use them to master in this particular area. So that's why I am giving so much detailed example, so that you can understand how the things operate. But until unless you try it at your end, you will not get the perfection of using regular expressions. I would suggest to try, and please don't forget to comment once you have a trial. Okay, so we're done with this particular slide. Let's move on to the next one. Direct replace and match count. So in this section, we'll be writing our code in the pink box, while the output will be shown in the black box. So here goes our TCLSH. Then we set our string, set sample, where there is a will, there is a way, and replace a word. Here we are directly, we know that there is a word and we can replace. So you're using the reg sub directly, which earlier few slides back we have used inside a if, but here we can directly use it. So I have given this example to make it clear that things are not have to be only in a particular way. We can manipulate, or we can use it in a different way. That's why this example, reg sub way, and then the target string, and then whatever we are replacing with is the abundance word, and then we are outputting in sample 2. See, here we are not actually overwriting the original string, but we are dumping the value in another string, the sample 2, and here we echo the old string and the new string. Okay, these are two strings. So the first string, which is a source one, is untouched, and the output has gone to the another one. So you can see the old string where there is a will, there is a way, and new string is where there is a will, there is abundance. So this shows you an example, typical example of reg sub, how you can use in a very non-destructive manner, so that your original string remains intact, but the output will be given, and you can check that output. Okay, use that all options. Okay, how is use it? Okay, so here I have directly used inside the puts command. The number of matching words is regexp dash all. Then I have used the regular expression starting with the rectangular bracket within is the caret, then plus. Okay, so and operating on the $sample. Number of matching words is 9. So this gives the count. Okay, so when we use all only, and in this way what we are matching is comes as a word, the number of matching words, there is a word count in this particular string is 9. So guys, there is enough number of trials. You can do multiple kind of manipulations in this reg sub. I would like to suggest to try at your end and come back with a comment. So we are done with this slide. Let's move on to the next one. File input output. So this is a very important feature. Before giving any example here or starting anything, I'd like to mention that whenever you are using inside a particular tool in VLSI shell, whatever data you are getting from a live design, right, you need to make a copy to the disk. Okay. Otherwise, if you flush it in the directly in the shell, right, it will be outputted, you can see, but you will not retain once you have come out of the shell. So this is a particular purpose that we need to do the file IO operation. Okay. So we need to write into a physical file into the hard disk, and then we can use that data for our analysis purpose. Okay. How we do it is that, and these codes are perfectly goes inside the any well-known VLSI tool, which I have discussed in the episode 1. Okay, which if you have not seen that, then you please go and see. You will understand what I am talking about. There I have explained how we use APIs inside a particular VLSI tool and we access the live design data. And here how we can dump the data that we have extracted using the APIs. So here goes our first line, which is a TCLSH. And then we use a set fread, and then in the rectangular bracket use open infile.txt then r. So here simply we'll see the example of a reading of a file and a writing of a file. And most in the case of VLSI, you will be doing the writing of a file because you will be extracting the live design data, you will be dumping. So, but it's good to know in the both ways we read and write. Okay. So fread is a file handle here, and in the rectangular bracket you see open and then the file name infile.txt, and r is the mode of file operation, R for reading. Okay. And we set fwrite. This is a file handle for write is a file handle for write file. Okay. In which we will be writing. So open outfile.txt. This is the name, and modus of operation is W. W is writing. Okay. So here we are using the while block to read the input file. While bang EOF means end of file $fread. So EOF, whenever we reach to the end of the file, it will flag 1. Okay. And while it is not the end of the file, we keep on continuing. Okay. And that time when we reach, right, it reflect 1 and not operation on that will become 0. So while will come out. Until and unless we reach the end of file, this return for each line, it remains 1 because that is 0 and not of 0 is 1. So here let's set line. So each line will be capturing in the line variable gets. Here to get each line we use gets $fread. Removing the \n character. Okay. So set line string write line then \n. So if there is some \n, we are removing it. So it's just for the purpose of the code I have given. It is not always necessary. Then we echo puts line. So here we are checking what we are getting from the infile. Then converting to uppercase. Okay. Set line string to upper $line, and here we are using the set command, and here we are string just to upper. So what we are doing, we are using a string operator just to change the $line to uppercase, and here what we do is this. Then what we have done the change from the input file, that we have changed each line to the uppercase. Okay. And then we use puts command and then the file handle and then the line. So we use the same puts command that we are using earlier, but now we are using with a file handle, and it is going to write in the file instead of your display. Okay. So if write then $line. We close the while loop here. So this is a very simple example, and here we have to close the file handle fread, and we have to close the file handle fwrite. So this explains the entire file IO operation. So reading a file and writing a file. Mostly in VLSI operations, we will be writing a file. So I think it is very easy. You can use that. In that case, you will be using the puts, then $fwrite, and then whatever line or whatever things you are giving in a double quote. Okay. So you can use these options. Please try at your end and let me know. Okay. So these text files, you can take any file of your choice, and it could contain normal text. Okay. So you'll see how things are changing. So let's move on to the next slide. Named code block. So here goes our code. Here is our TCLSH. Then we write the set script. So this is the name of the code block script, and the code block begins with a curly bracket. Set number 11. Set number 2 34. Result is set result within rectangular bracket expr. Then we add these two numbers. Okay. And here we close our code block with a curly bracket. Okay. So here how we eval this code block is use the eval command and eval $script. So this is how we define a code block. Okay. And we execute inside a particular script. So this might become sometime useful. That's why I have given the exact example. So you try at your end and let me know. Okay. inbuilt mathematical function. This next section is. So here we are not going to in explicit details, but I will just touch base on the basic mathematical functions in Tickle for sake of your knowledge so that you can use them readily. Obviously, you have to consult the particular manual, okay, the Tickle manual, which I have shown you in the first episode, okay. So here, these functions are available, like absolute, a cos, a sin, a tan 2, okay, boolean, cos h, okay, exp, if mod, hypotenuse, okay, I sqrt, log 10, okay, max, mean, power, random, okay, sin h, sqrt, and then tan h, wide. So all these mathematical functions are there inbuilt inside the Tickle library, okay. So you can use them. You consult the manual for each case how you are operating on each of these mathematical functions when you have to do some of the computations inside your script. TCLSH command. Here in this section we'll just touch base. If you are using the interactive shell of any of the VLSI tool, you may need these particular TCLSH commands, okay. And these are very similar to the shell or terminal that we use in a Linux, okay. CD, we know, change directory. It is same in TCLSH. History, it is also same as our normal bash or PCSH shell, okay. History is just to see the command history, okay. Exit, to exit the prompt, okay. Error, so this is another very important command. Just if you execute this error right inside your Tickle code, this is not exactly in TCLSH shell, but you can use it in Tickle code. You can echo any error. So if you are writing a Tickle script and you need you are doing some output, right, you have to put some error message there. You can use explicitly the error, okay.
Hey guys, welcome to the 10th episode of Q&A in Tech Simplified TV. We are having a very important Q&A covered in today's episode regarding a very basic but very important Tickle regular expression. Viewer Komu Vijayasagar has done some changes in the code shown in the 5th episode of Tickle in VLSI series. He is facing some strange outputs and wants to know the reason. So, in today's episode, we will zoom into this particular situation. Stay tuned till the end of this episode to know how to do the root cause analysis. We are in our computer screen and the viewer's question for today's episode is, Umo Vijayasagar asked that I have replaced plus with a star for the expression set result regexp, then az star $sample, then match 2, and the output is match status is 1 and match string is blank. Why the output is blank? So he has asked this question in the comment section of the 5th episode of Tickle in VLSI, where we have discussed the regular expressions, and he has asked the question based on this particular snippet of the code. So here you can see that here he has substituted this plus with a star and he is asking why the result is coming blank for this $match. So we will explore to the code experiment in upcoming slides. We are done with this particular slide, so let's move on. Meta characters in regular expression. Before proceeding any further, I would like to mention one thing here, that meta characters are very much important in regular expression. Now, what are the meta characters? Let us just brush up the knowledge once more. Caret matches the beginning of a line. Dollar matches the end of a string. Dot matches any single character, that is any alphabet or any numeric character. Star matches the count or the number, that is 0 to n of the previous character after which this star is placed. Plus matches any count or number but at least one of the previous character. Now let me bring my mouse to make the difference in between the star and the plus. This I think these three are very straightforward to understand. This for the beginning of a line or a string, this is for the ending of a line or a string, and this is matches any alphanumeric character. Any means any. Star matches the count or number 0 to n times of the previous character. Means if we place star, whatever character or alphanumeric character we are placing the star afterwards, that particular thing should have been matched 0 times or up to n times. For plus, this matches only at least 1 time. So here the match could be 0. Now you can see that in the expression where Komu has found that there is no match, so it has gone through the occurrence 0th occurrence, because he has replaced plus with star. And if we want to find at least one occurrence, then we have to use plus. Now let me elaborate through the examples. Meta characters experiment. Here I have done some experiments for that particular code snippet. So here goes our code, and here goes our output. I have kept two different placeholders. The pink is one for the code and the black is for the output. So here goes our hashbang user bin tcl-sh. You know, this is for invoking the tickle shell. Then we write our string, that is set sample, where there is a will, there is a where. Then match the first substring with lowercase letters only. Set result, then regular exp, then a to z, then plus, then $sample, and then match. So this expression, when we give a print command, that is puts in tickle, here I have modified the first one with ms1, okay, the status one, and which will capture the result capture the status, whether this has executed or not. The next one is mstr. This gives the matched string. So this gives the status of the execution of this particular block, code block. The status goes to result, and the $match captures the match substring. So when we do this, execute this particular set of code, we get the match status is 1, and the match string is here. So this means 1 means nothing, but this has executed. In case there was some error or something, here we have got some other code. So the 1 means it has executed. Next, I have modified the particular case with star. You can see here I have put star, and here everything is same. I have just renamed the variable match2. Ongoing examples coming downwards, I will keep match2 and I will keep on experimenting. So here a to z means this is for, there could be any combination of characters from a to z that is in small cap. This we have to be very sure. If you look here, this is only the small alphabets here, and this here we do not have any here in this particular string. This here is from HERE. We are excluding W because it's a uppercase and the regular expression is picking up here HERE. So now let's go to the next code experiment, and here if we put output, then what comes? Now when we put star, that means as per the description in the previous slide, this star will match 0 times. So it has matched 0 times, and hence although the code block has executed giving the status 1, but there is no substring has been passed on to match2. So that is the reason this is blank. This answers Komu's question. Now let us do some experiment more to understand the scenario. Now let me do change here. Here I have changed a to z and then small caps a to z, upper caps a to z and small caps a to z. I have kept the star constant here. So I am changing one at a time. I am changing here. Rest of the expression is same, and here it is star a to z a to z. Now if I print this, what will come? So it prints where, because here the first string is upper caps, which is picked up from this combination, and then we are picking up from a to z, and hence we are getting where. Although in the first case we got the here 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 from where, but W was not printed because we are searching for only smaller caps substring. So here we have the combination a to z in upper caps and a to z in lower caps, both. So the whole expression is come here. So you can see, although we have given star, the star is constant. As I have changed this, it has picked up. This block has executed. So execution status is 1. Substring has been picked up as where. So now let us do some more experiment. Here I have changed the star with plus. You can see rest of the thing is same. What comes as the output? So again here it remains the same because it has to match minimum 1 time. Star has to match minimum 0 time. If you find okay, otherwise leave it. If you find 0 times even it's okay for star. For plus you have to find at least 1 time. So in both cases, since at the first go we have found where the output has come as where in both cases. Now this is a good question and this may be asked in interview. Now again I change the a to z expression with dot and then star. Rest of the expression is same. Here if I go and printed this out, here it comes that where there is a will, there is a way. The entire string has been passed on to match2 because we have mentioned dot. Dot means as a meta character it could be any alphanumeric character. So any means now star has to find at least 0 times. So any it has picked up everything. Now if I change star with plus, what happens? Now the output also remains the same because it has to find at least 1 time of the occurrence, and here since dot means anything, it has to pick everything of the entire string. So this way you can do some experiment with the regular expressions, and then you can find out your queries. You can change things and give a printout and change again another thing, give a printout. If you have a question you can ask me, there will be answered in the Q&A episodes. So this is all about the experimenting. So I would like to ask you to try out this thing at your end and do some experiment and come to your own conclusion. More details on regular expression. Now, when I was analyzing the question, I have realized that the concept of regular expression must be very much clear in your head. In my channel, I have two very important episodes. This is the first episode that is on sed in the bash programming in VLSI, where I have initiated the origin of the regular expression, the categorization of the regular expression. There are two kinds of regular expression, that is ERE and BRE. Those are available in this particular episode. You can pick that knowledge from this particular episode. And then you can move on to episode 8 of Parling VLSI. Here in this episode, I have explicitly given many examples of the regular expression and I encourage you to try them out. Now your question is, basically I'm trying in Tickle, but you are saying about bash and Perl. Now folks, one thing is very easy to understand, that the regular expression is not a property of any particular language such as bash, Perl or Tickle. The regular expression in Unix, it is independent and it is adopted in all the languages. So if you learn regular expression in bash or regular expression in Perl or regular expression in Tickle, you will find the common factors. Generally, we use the advanced regular expression nowadays. So there are two engines, BRE and ERE. I'll request you to find out them in the episode of sed and enhance your knowledge in regular expression. The regular expression is such a thing, without practice, you cannot get all the power into your hand. So you have to do practice and you have to experiment with the regular expression. Then only you achieve the power in your hand for the regular expression. We are done with this slide. Let's move on. Hey guys, welcome to the 12th episode of Q&A. We are having a very important topic covered in today's episode from the series of Tickle in VLSI. Viewer Rajesh Shah has asked the 5th episode of Tickle in VLSI, can you make a short video on namespace used in Tickle? So in today's episode, we will zoom into this particular topic. Stay tuned till the end of this episode to get full hands-on knowledge. Hey guys, welcome back. So we are dealing with the question, can you make a short video on namespace used in Tickle? Question came from Rajesh Saha, who is a viewer of Tech Simplified TV. And he asked this question in the comment section of 5th episode of Tickle in VLSI. So we'll be jump starting the topic today, right now. So let's move on to the next slide. What is namespace? A namespace allows you to place a bunch of code under the hood of a name. This name is generally given by you. Thus, any naming conflicts with classes, functions, and constants, etc. are avoided between the two namespaces. So, this means that basically the namespace actually segregates different section of codes and protect them from each other. So, this way the namespace helps in coding. It allows your code to live in that particular namespace. Hence, encapsulation of data and functions are done in various programming languages. So the point I talked just now, that the segregation is another way we can say that data and functions are encapsulated. That is, they are segregated and they are encapsulated inside a particular block, and that block is called namespace. Namespace hierarchy separator is generally double colon, and this is common in many programming languages, not only Tickle. In many programming languages, this double colon is used. We are done with a short and sweet definition of the namespace, so let's move on to the next slide. Namespace hierarchy visualization. In terms to understand the namespace concept, we'll have some infographics here. So this bigger block is the built-in namespace. This is the block when you start writing your code inside a file. Not only Tickle, any programming language, when you are writing a code, you write somewhere at first, right? Where you do not have any other things written. You just say write a print hello world, and that space is called the built-in namespace. So that is the default namespace where you start writing the code. This is true for Tickle. Next comes the global namespace, and generally this is written by the user, that is you. And this is a way we have to learn how to write a namespace in each and every programming language and also in Tickle. Sometimes we create a further down namespace, which is also called a local namespace. And this infographics now tells you that you can go deeper and deeper in the hierarchy inside the global namespace. So there will be local namespace 1, local namespace 2, and you will go further down inside in the similar fashion as this infographics has been shown to you. The visualization of namespace, I think we have covered, and let's move on to the next slide. Namespace creation in Tickle. So this is a very important thing that you should learn, because when you are learning to create a namespace, you will be able to encapsulate your Tickle data. So this pink block will contain our code, and finally at the end we will show the output in the black block. Hashbang user being TCLSH, the first line. Then creation of a namespace. An example is a up counter. So the namespace here, the code we are writing is for a up counter. That means a counter that counts up. We'll show how the code works. We write like this: namespace eval, then counter. Here the eval is a default keyword in Pickle, and the namespace name here is counter. And the namespace keyword at the beginning, and this means that we are creating a namespace. Next, we define a variable num1, and the variable keyword is used to create a variable number, and we set a value 1. Then we start writing a procedure. Generally in Tickle, whatever we have the subroutines or functions, that is named as procedure, that is proc. We already talked this in our initial episodes of Tickle. So here the proc definition is there. So this means up to this line we have both the data as well as the function inside a namespace defined. Now let us write the body of the increase procedure. We write variable num. We write return increment, then num. So this incr will increase the num variable by 1. And thus we are done with the coding inside the procedure, and we close the proc block. So here we return both the data, that is variable, and the corresponding function, that is procedure here. And for your curiosity, I have put a puts command inside this particular namespace, so that when we are giving a printout at the last, which will come into the black block, there you can differentiate between from where we are printing. So here I have used the keyword inside in upper caps, okay, and printed the num variable. Here we close our namespace. So this is a basic structure of a namespace in Tickle, and we have defined the up counter here with this particular code. Now let's move on to the next section. Adding a proc or variable in the above namespace. So we have closed the namespace, but we still want to operate from another part of the code. Say this may not be the immediate part or immediate line. It may be sometimes later on. In that case, how we write it? So let us see. We write again namespace eval counter in the same way, and we write variable clock, and we set a value 5, and then we write a proc hello, and the argument is blank here, as like in the increase, and we start the writing. Here puts hello world, and we close the proc. It's a simple proc. It's a hello world giving output in the screen. And here we again put a puts command inside the clock, that is clock is equal to $clock. So this will answer your curiosity that from where the print is coming. So here in later part of a code, we again added some more function and variable here. So we're done with this particular code lines, and let's add some more lines. Printing a variable outside its namespace. Puts outside, that is num $counter : num, and outside clock $counter : clock. So this way we give a print. Let me bring my mouse. Here you can see that this is the name of the namespace, and we have a hierarchy separator : and then we give the number, and here we give the clock. So number is defined here and the clock is defined here. Now let us give the next line. Executing a proc from outside a namespace. Counter : increase. This procedure we are executing. So we given the namespace, then : increase. That means we are calling this function from this particular namespace, from counter. Namespace, then separator, then the procedure name. Next we have given the print command here, that is puts command outside num counter. So here we have executed this, so this means the counter will go up, and then we print the num variable again. Then we are accessing the second function we defined later here, that is hello world, counter : hello world, that is hello. The function is hello, and removing a procedure in the above namespace. So if we want to remove any procedure, how we do that? So we write again namespace eval, then counter, and we rename, say hello, we want to remove hello, then we give a null character here, that is double quotes, back to back, there is nothing inside, and we close the code. So once we print this out, what comes here, right? The first one is inside num1. So if we see, this is inside num1. This value is printed here. Next, inside clock 5. So it is coming from here, inside clock 5. The next print comes as from here. And these two, so these two are counter from here, from outside. So previous two came from inside and the later two came from outside. So here these things are printed. So the next one is printed from the outside. Okay, so this is outside num counter 2 after we have increased. Okay, and then we call the counter hello, right? So the output comes as hello world here. So this way our code executes, and finally we have removed, so we are not checking anything because we have removed it. So if you try to execute this counter hello after this one, it will give some error. I would like to request you to try out that in your end. So we are done with this particular slide. So let's move on. Namespace hierarchy. So we already have done the visualization of the hierarchy. Come to the code example. The pink blocks contain our code and the black box will contain the output. So let's start our code. User bin tcl-sh, that is the first line always, and then we have the built-in namespace. The space where we are writing our things is the built-in namespace. You can correlate with the infographics. Then comes the global namespace. Namespace eval, then top. Then variable test. So we have defined here the namespace eval and top. I have given the name top just to map it with a top level namespace, and the variable inside we given a test, and we are going to define the local namespace. And here we write the namespace eval within. So top means it's at the top and then within. I have just used the words in the same way just to map into your mind. Next comes the line that is procedure hello. Okay, and here our procedure is that, and it's a hello world, and it prints out the hello world, and we close it. And here we close this one. So this closes this, and we close this internal, that is local namespace we have closed here. And here we close the total, the overall, the top level namespace. So this one here to here is the global namespace defined by the user, and here to here is the local namespace, again that is defined by the user. By name you can identify top and within. That's why I have kept these names just to identify in a right fashion. Changing the variable and printing value. Now we write here set : top : test is equal to 25. So this here you can see that we do not have any text before it. So here when we write, right, there is nothing before. This means this is from the built-in namespace because there is nothing here. Then comes our top, and then we write the value of this variable test with 25. Now we print this out, and I will come here later. Accessing a proc defined inside a local namespace. Sorry for the typo here, and here top, within, and hello. So here we are accessing these things. How? First our built-in namespace, then our global namespace, and then our local namespace, and then we have the hello. So you can see how we are using the hierarchy separator. At the very beginning we are not mentioning anything because we do not have a name for the built-in namespace. So there is, the name is here blank, and then we go down, hierarchy down, and reach up to the hello function. When we print, 25 is printed from this puts command, and when we execute this, it gives the hello world. So this way our hierarchy is defined in Tcl namespace. So folks, we are done with this particular slide, so let's move on. Namespace export and import. The two pink blocks will contain the code and the black box will contain the output. So let's start our code. First line is user bin tcl-sh. Second line we define the namespace eval space and we write procedure, that is mul, meaning of multiplication. So we'll have couple of mathematical procedures here, they're upcoming. So a and b is the argument. Then what we return, that is multiplication of a and b. Here return value is expr and then $a $b is multiplied. So here our procedure mul is completed. Next we start the sub. This is subtraction. Inputs are AB, and then we subtract $a minus $b and return this value. We close this block and then we give a division. A and B are argument and return value is expr $a by $b, and thus we close it. So these three procedures we have defined inside the namespace space. Okay, I have just given here a generic name space. From inside exporting to outside. So whenever we have to export the code to outside, the concept of exporting is that we are crossing the boundary and we are throwing out these procedures outside this particular namespace into the built-in namespace. Or if you are inside the local, you are throwing out, it will go to the global. It's a very relative factor. From where you are throwing out, it will go outside immediately to the next block, which is above in the hierarchy. So here we use the namespace, then export and star. So you can see I have used wildcard. You can use the names also. You can export mul or sub or div. Yeah, it's your choice. Whatever I have done is I have exported star. Everything means everything here will be exported to the just outer block. Now from outside we have to take them in our namespace. So this is not a just one step process, it's a two-step process. First we export from the particular code block and then we import that in the block where we intend to use. So namespace import space : start. So import is a keyword and export is a keyword. These are two keywords for export and import. Next, what do? We set result mul in 5 into 2. We print out the value, then sub 5 2, then puts the value, and result div 5 2 and puts the value, and deleting all the imported items from the present namespace. So if I write that namespace forget space : star, whatever we have imported here will be removed from our present namespace. But this is still valid. This will not get invalid. Whatever we have called through this statement, this will do the exact opposite. And after that, if we set result div 5 2 and try to put sub, let us see what we'll get. So first here, this result comes as multiplication 5 into 2, 10. Next 5 minus 2 is 3. Next is 5 division 2, that is 5 divided by 2 is 2. And here, since we have done the forgetting here, that means we have deleted all these things whichever we imported. As soon as we touch this particular statement, it gives a error, that is invalid command name div while executing div 5 2 invoked within, and then it gives the rest of the message from this particular one. So this way we can use the import and export process inside the namespace. So we are done with this particular slide with the examples, and let's move on. Hey guys, welcome to the 14th episode of Q&A. We are having a very important topic covered in today's episode from the series of TCL in VLSI. Viewer Krishna Kittu has asked in the 12th episode of Q&A as a continuation of TCL in VLSI, is it sufficient to learn TCL till the file IO, or even creating and reusing packages, namespace and libraries are also needed? So in today's episode, we will do comparative study of source versus package method of code reuse in TCL. Stay tuned till the end of this episode to understand the difference. Hey guys, welcome back. In today's episode, we will be discussing about what is source command in TCL, TCL block that to be sourced will write a program. We will be using that block in another TCL code by sourcing it. What is a package in TCL? We'll write a code where we'll define and write a package. Then we'll build the package, which we also can call the packaging of a package. We will cross-examine the auto-generated file as a build procedure. Generally, the name is packageindex.tcl. Finally, we will use the package, that is the code reuse, and we will analyze its output. So that's the menu for today. So without any further delay, let's begin. Viewer's question. So today we are dealing with Krishna Kittu's question, and he asked this question in the 12th episode of Q&A, where I have discussed what is namespace. So namespace has a very close relation with the package in TCL. So today we'll encounter that thing. So let's begin. First, we'll talk about the source command, and then we'll move to package, and this is how we will see the difference, and we'll come to the point where we can see the benefits of using the package over the source command. Obviously, for that also you have to get familiarized what is a source command. Now, what is a source command in TCL? The syntax is source then file name. File name means not only the name, it includes the full path of that particular file. If the file is in some directory of the current directory, then a related path will also be sufficient. This particular syntax reads the TCL script contained in the file name and executes it. So one more thing I would like to tell you that this particular source command is widely used in the VLSI tools, where they have a shell that interprets the TCL code as well as their own APIs. So sometimes you have to write a code using the APIs of that particular VLSI EDA tool, and you have written a program where you will fetch P4 different entities from the design, and all those things you will be writing into a physical file in a disk. Say suppose you have written this in a particular TCL file, then how you use that in the TCL shell of that particular EDA tool. So that time you have to use the source file name, this particular command. So this source command is not completely irrelevant. However, when we compare the source command and the package command as a point from the TCL itself, we'll see the difference. So let's move on.
This allows a single bigger tcl script broken into multiple smaller scripts, each part corresponding to a specific functionality. Now, when we are talking about this point, we are thinking in terms of tcl scripting only. Say we have written a file, first we have parsed a file, then we have done some processing on the result, then we have dumped an output file using the processed result. So there are 3 sections. So you can split the 3 sections in 3 different files of tcl script, and then in a further program as needed, you can source them at 3 different points. So this way, a bigger tcl script can be broken and sourced into the program. So this could be very much true for even when you are running the live design shell inside any VLSI EDA tool. So whatever example I have just now given, it can be applicable there also. This is the utility of the source command. This allows the code reuse with localization and limitation. Limitation only you will come to know when we go to package. Before that, I cannot show you any limitation here. And this code is very much localized, that it is staying in some A/B/C path of some hard disk which is shared in the network, and you have to use that particular path to use that particular code. And this will be one of the limitations. So you are stuck in a particular path and file. So you have to keep a record of that particular file, path and everything. So next point is you cannot use the reusable code treated as library. Now, what is a library? Well, library, we have some predefined functions, we have some predefined variables. All of these predefined things will be kept in a library, and they will be used as needed whenever you need, and a specific way you can call those procedures and etc. However, the methodology I just discussed here, that you split a bigger tcl file into smaller parts and then you use it, do not give you the feeling of that use this as a library. To use it as a library, we'll use package. Before that, let us see how the source command can be used. I'll take one particular example which I have used in the namespace, and once you see the code, you can recognize that you have seen this particular code in the namespace episode. So let's move on to the next slide. File structure, source example. Now this is very important why I'm speaking. I have split the entire experimental code into 2 parts. The first one is source example 1.tcl, which contains the code which has to be reused. The next part contains the use of this code, and the file I have written, that is source ex2.tcl. Why I am saying this name of these files? Because once I share you the outputs, you will see these names there. So that's why I am pinning all these things into your mind right away in the very beginning, so that you can actually relate when you see the output. So in our working directory, there are 2 files, one where we have written the code, and in the second tcl file, we have used it. That means the reuse of the code. So we're done with this particular slide. So let's move on. Tcl block to be sourced. Here, this particular pink block will contain the code. We start our code with the hashbang user bin tcl-sh. We write the procedure of multiplication with 2 arguments a and b, and we have the return statement as a multiplied result, and we close it. Similarly, we have the subtraction a and b. We have the mathematical expression in this next line, and we close the procedure. Third one is the division. Here we also have 2 arguments, and this line contains the mathematical description. This is very straightforward, so I am not going to explain this. And I close the bracket. So here there are 3 tcl procedures. One is multiplication, one is subtraction, another is division. So these 3 I will be reusing in the next code. I saved this particular file in the name source ex1.tcl. This is just to remind you and emphasize. So this slide we are done. So let's move on. Sourcing the tcl block. Now that particular file I have written already, saved and closed the file. Now I am opening a new file. So here the pink one will contain the code, the black one will contain the output. I begin the code with hashbang user bin tcl-sh. We get the present working directory. How? With this particular command set, then we name a variable this directory, and we execute the tcl command pwd, and that's how we get the present working directory. Now present directory, whatever this variable, it will contain the full path and it will not contain the relative path, just for your information. We will use the source command source, then $this directory /source ex1.tcl. So this execution of this particular code will expand this directory variable into the full actual physical path, and then it will append the source ex1.tcl at the end. So this is how the tcl code will be able to see the previously defined code. And here next we call the procedures that we have defined in ex1.tcl. We give two arguments 5, 2 and we print the result. Next we give sub then 5 and 2 and then we print the result. Next we use the division and with the argument 5 and 2 and we print the result. I hope you can recall this thing. I have already used this same code in the namespace episode. You are already familiar. So let's see the outputs now. First one gives the output 10. Second one gives 5 minus 2, 3. Third one gives 2, that is 5 divided by 2 is 2. You can see that we have defined a particular tcl code and we have used the source command in the next file, and here we reusing the code. That means whatever procedures we have written there, we are using it here. And this is a very pretty simple method of code reuse in tcl, that is source. Now we are done with this particular example. Let's move on. What is package in tcl? Packages are used for creating reusable tcl code library. The example for source command that we have seen is a very pretty simple and straightforward. You can use it in day-to-day use. But in case you are in a very big VLSI company where there are 20 or 30 designers, they are using the tcl code regularly in various projects. So in that case, you need to build a library if you are the one who is doing the tcl coding. So for that purpose, you can use the package definition, because once you do the package, right, you can versionize it. I'll come to that point. And the packages thing is that once you package it, okay, let's see the benefit rather than speaking ahead. Namespace is used to encapsulate procedures and variables in the defined package. So this is another beauty of the package, that we can use the namespace. I have already created one episode in the namespace and I'll also provide the link in the description so you can watch that episode. What is namespace and how in tcl we use the namespace with the examples I have explained already. This namespace is very much useful in localizing procedure and the variables. And once we make a package, the entire thing is encapsulated, and with the help of the namespace, the capsule is completely tightened and the code is very much secure, so you can reuse it in a very good fashion. It will not get mixed with any other codes in the existing main block of your tcl code. So what will happen? That you will retain the sanctity of the code reuse from the package, that is tcl library. Now next is the package can be a collection of tcl scripts, binary library, or a combination of both. So this is a kind of, the binary library is a kind of advanced side. In today's episode we are not going in that direction. We'll stay with simple understandings so that you can use it right away after you see this episode. We are done with the definition of the package, and now let's move on to hands-on example. File structure, package example. So in our directory, this is our working directory, we have created 3 files. The first one is package1.tcl, where we have written the code of the package. In the second script, we have written the necessary commands to build this particular package into a library. Third, this is our final code where we are using, that means reusing our tcl code that has passed to the build command, and this is how we are reusing the command. So now these 3 files are in our working directory. We'll start with package1.tcl, then we'll move on to package2.tcl, and finally we'll move on to package3.tcl. So let's move on to the next slide. In this particular slide, we will be writing the package and you will learn how to write a package, what are the necessary commands. In this pink block, the code will be there, and since we are writing the code of a package, we can execute it to check any kind of error or warnings are coming or not. But however, here we will not get any output as per this particular code. And just to remind you, this is the package1.tcl file which I have just mentioned in the last slide. So the code begins with the user bin tcl-sh. Next, we register the package name. Here is the command for this package to be defined. First word is package, then provide. Then we give the name of the package, that is mathf. We are defining some mathematical functions. So I have abbreviated it as mathf and I have given the version number 1.0. So the first field and the second field, these 2 are necessary. The third field, you can choose the name by yourself. Obviously, it would not clash with any pre-existing tcl library. And at the last,
you give the version number. So this is one of the benefit of the tickle package, that you can have different versions. Once you change in a code or once you upgrade the code, you can change the version. So let's go to the next line. Include the basic tickle with versions inside the package. So this is another important command, that package require tickle 8.5. So this is how we call any particular package. So package require means we are calling the existing library tickle and with the version 8.5. So this is another example we are using. So tickle 8.5 is the library version and we are calling the package tickle. Why we are using this? That this particular package should be compatible to the all procedures and variables whatever are there in tickle 8.5. So here we create a namespace same as the package name, easy to remember, and we can later use it. We give the namespace eval. You are already familiar with this particular syntax from the namespace episode. In case you have not seen, link is given in the description. So namespace eval, the name is mathif and we start with a curly bracket. And here we write our procedure, multiplication a, b are the two arguments, and we have the mathematical expression here. And we close it. Similar way, we define the subtraction with two arguments a and b, corresponding mathematical expression. We close it. Next, we write the division procedure with two arguments a and b and the corresponding mathematical expression, and close it. And finally, we close the namespace. So you can see this three different procedures we have already used in the source example. So we are using the same. The method we are using here is the package, and we have already displayed the necessary commands to define the package, and here our package is complete. So we have defined the package, and let's move on to the next slide. Build, packaging the package. Now we have saved the first file package1.tcl in our hard disk, and now we have to build this particular package. For that we are writing another file. So in this pink block our code will be there to build the package, and in the black we will get the output once this is executed. Just to remind you, this file has the name of package2.tcl. So here we have hashbang user bin tcl-sh as the first line. Then we get the current working directory by using this command, set this directory, and then we have the tcl command pwd. So we fetch the present working directory inside the variable this directory. Then we will use package mkindex. This is a tcl command. This will build an index for the automatic loading of the packages. Now this is the command you have to use. So package mkindex, let me bring my mouse. So this is package mkindex. Verbose means whatever we are doing inside this, they will be displayed in the output screen. Then we have its commands, file, then join, then present working directory. And we are writing the file names is a generic pattern. Dot is the present directory, right? And the package is star.tcl. So here we are writing package1.tcl, package2.tcl, package3.tcl. So this will be star will replace this number. So I have written package3.tcl. This line you don't have to do much thing. Only from here to here you will keep it constant. Here only at the last field you will change whatever file name you are giving to your particular package. So this only field you have to change in case of you try it at your end. Rest of the things you can keep from here to here. You can keep it intact and as is. And this is a dot and it's not a mistake. Okay. Here let me get the output. So once we execute this particular tcl code in our terminal, what we get? First we get successful sourcing of package 3. Basically this package mkindex, it will read all the files that comes under this particular wildcard expression and it gives on output. So package is provided here and it parses the package2.tcl. So next comes, since we have successful sourcing of package1.tcl. So in package2.tcl, I have written here in the slide, I have not shown the package 3, but in case my directory that already contained the package3.tcl. So it scanned all the tcl files. And the most important file is package1.tcl. That's why I have made it with a different color, the green color. You should emphasize here. In package1.tcl, our package is written. So whatever the lines are coming next are very important. So watch it carefully. Package provided where mathf 1.0. So it has already read the package name and its version. It processed the package that is written in package1.tcl. So we have given this mathf and the version number that it recognized with this particular command, package mkindex. In this side we have done the build. Now as a build will come with a new tcl file. Let's see it. Auto-generated file, package index.tcl. So here is the file. It is auto-generated. So I have just displayed it at once.
And also you have to remember this is the auto-generated file. That means it is generated by the package mk index. So what is written here? The tickle package index file version 1.1. This file is generated by package mk index command and post either with an application starts up by a package unknown script. It invokes a package if needed command. Okay, all these are tickle commands. They can be used package related information so that the package will be loaded automatically in response to package require command. So this is the most important. So package require whenever we use and we use the mathf, right, 1.0. So this file will be needed. It creates the junction of our package and the tickle interpreter, that is TCLSH. With this script is source, the variable $dir must contain the full path name of this file directory. I'll not do any experiment here because this is auto-generated file and you also should not touch here anything. So this is kind of auto-generated. It came as the build procedure have been executed, and just for your information, that is FYI kind of purpose, I have displayed this file. No need to change here, no need to do anything here. We will move on to the next slide. Use of the package, that is code reuse. So here first in this slide we'll write the code to reuse the math function package that we have already defined. In the next slide we'll show the output. Remember the file name here is the package3.tcl. First we start our code with the hashbang user when tcl-sh. Next, getting the present working directory. You are already familiar. You have seen the example only in this video. To set that this directory and the tickle command pwd. Then autopath, $autopath is a variable is to store a list of directories which contain tickle packages. So this is a very important. This you have to use. So here I am printing the autopath originally before we make any change inside it. And then we use the append autopath and then this directory. So we are appending the present working directory to this system variable of tickle. And after that we also print the modified autopath so that you can see the physical difference what have been modified. And then we use the package require mathf 1.0. When we have to use the tickle package that we have written somewhere else, that is package 1.tickle in this particular example, you have to use package require mathf 1.0. Next, we set the result mathf : mul then 52. If you have seen the namespace episode, you will come across this particular syntax, that is mathf : multiplied. In case you have not seen that episode, link is provided in the description. So go ahead and watch that particular episode. Here we call the multiply function from that package mathf and we give the two arguments 5 and 2. Then we print the result. Similar way we call the subtraction with two arguments and print the result. Similar way we call the division function with two arguments and we print the result. So this is our code. Our code is done. Let's move on to the next slide to see what output we get. Just take a mental snapshot so that you can compare the result. So there are 5 lines will be there. One first original autopath, second modified, third will be multiplied, second then the subtraction, then the division. We are in this next slide where we will see the output of our already written code in last slide. Here comes our output. The original autopath is this and here the modified autopath. So I have marked the difference with the green color that you can easily identify. So presently in this particular tickle test directory which is marked in green, here you can see I am pointing with mouse. In this particular directory I have written the code of this particular tickle, and when I use the append, it got appended in the autopath variable. So all with the pre-existing paths, this particular directory also get appended. Now once this code executes past that, we get the output of the 3 different mathematical functions as is. So this is the code reuse in terms of package. So folks, now you can understand that how the package thing is different from the source thing. Package thing is a much more systematic way of managing a code and using it in a very systematic way. You have a version, you have a proper namespace. When you use it, it actually calls the variables and procedure from that namespace, and there is no chance of clash or collision with your existing variables in your main namespace where you are writing the code. Keeping all this thing in mind, the package thing is a much better way of encapsulating a tickle code and use it as a library. However, for small use, you can use the source. Generally, that is a very widely used practice in VLSI to use the source. However, if it is possible, you can use the package. However, one point to be noted, instead of source, if you are using the package, right, in that case, you have to consult which API you have to use to link this package to to your VLSI tools interpreter. So here we have used the build command, that is for the TCLSH. However, that is the VLSI design tool, whatever you are using, maybe TNR or something. There you have to know which particular build command you have to use. That will be solely for that particular VLSI tool. This difference only will be there. So you have to be careful that you should not make an assumption that whatever I am doing, the 3 steps here will be exactly same there. It may be same, may not be same. So in that case, you have to consult the respective tool manual and have to be very much confirmed that you are using the right build command. Okay folks, we are done with this particular slide. So let's move on to the next slide.
Hey guys, welcome to the 15th episode of Q&A. We are having a very important topic covered in today's episode from the series of Tickle in VLSI. Viewer Krishna Kittu has asked in the 5th episode of Tickle in VLSI series, can you explain about the usage of eval command in Tickle? Previously, he have asked, can you explain us about the exec command? So, in today's episode, we will do comparative study of eval versus exec in Tickle. Stay tuned till the end of this episode to understand the difference.
Hey guys, welcome back. Here is the menu for today. We will first discuss what is exec. Next, we will discuss simple use of exec. Next, we will discuss EDA automation use of exec. Next, we will come to the point what is eval. Then we will go through a simple use of eval. Next, we will explore the repetitive use of eval. Next, we will summarize our entire observation. So, this is the menu for today. Without any further delay, let's begin. So guys, today we are discussing the question from Krishna Kittu, and who has asked that we explain about eval and exec. His comment was there in the 5th episode of Tickle in VLSI. So let's move on. What is exec? The exec command executes a system command that is binary from Linux or Unix while staying inside TCLSH. Now this is the definition, because whatever we execute inside Tickle, all they are Tickle procedures, and in case you want to access any outside binary, that may be from Unix, Linux, or in case of EDA VLSI, it may be a EDA VLSI tool or some kind of post-processing tool that would also be there. So that has to be called from within the Tickle shell. So exec is used for this particular purpose. If you have seen the Perl episode, there are 2 commands. One is a system, another is a backtick. They have similar kind of application there inside Perl. I told this because you can correlate, compare and learn. Let me move on to the next point. The exec command treats its argument as the names and arguments for a set of programs to run. So, if there are 3 space separated texts which we give to exec, the first one will be treated as the command. The rest of the space separated text will be treated as the argument of that particular command. In VLSI EDA automation, any external EDA software binary can also be executed using exec while staying within the shell of a parent EDA tool. Now why I call parent? Because when say you are running a STA engine and you are inside the STA shell, like you have seen the open timer, right, in my channel. There inside the shell, from there if you have to execute a outside binary, this could be one of the measures that you can take. Generally, there are many design tools like maybe PNR tool, maybe STA, maybe there are front-end tools also. Those tools have their shell from where you can call the exec. Obviously, you have to check the compatibility with the tools shell and you have to use it as per the instruction in the tools manual. Now, why I have mentioned this point? Because in Tickle shell TCLSH, you can right away use the examples that I have shown. But in case of the EDA tools, they might have some wrapper or they may have some modified version of the exec that you can use there. So don't jump to any conclusion. You have to check and scrutinize before you use it. I'm done with this particular slide. Let's move on. Simple use of exec. So first, let us see an example where we can see the very simple use of exec. How this exec is used. Here goes code in the pink box, and in this black box our output will come. So let us start the code. The first line is hashbang TCLSH, this you already know. Then comes the comment, that is simple use of exec. Now here I write a command that set output and then I write exec then hello.tcl. And now what this hello.tcl, it's another Tickle script.
Here is the content of the hello.tcl. The first line is as usual the hashbang user bin tcl-sh, and then the puts command with hello world. So this way we are executing an external tcl script using the exec command. Puts output, so it puts the output and prints the output whatever we have received in the output command. Now when we have the rectangular bracket, it executes the exec or whatever tcl commands within. Here we are executing the exec. After that execution, whatever the result that will stored in the output variable, and then we print the output. This is way we are going to test the exec for the subsequent lines also. Here we write set output exec pwd. Pwd is for the present working directory. When we type this in our init shell, whatever directory inside the hierarchical path we are in, it will print out up to that leaf level. Then again we print it. Then I use exec with whoami. Whoami gives the user ID that with which I have logged into the Linux or the Unix system. Then I print it. Next, I use exec, then which tcl-sh. Here, with the which command, we are locating the path where the tcl-sh binary is stored inside the Linux or the Unix system. Then we print the output. Now, several things I have written in the script, and once I execute the script, these values come. Hello world, the first one that comes from the execution of the hello.tcl. Next, we done the exec of the pwd, and that gives the output as the full path up to the directory inside which I have executed this particular script. Next, whoami returns the username. Here it is msg, and here in case you are logged in your system with any name Rahul, so it will return Rahul. And next, we queried the tcl-sh path, which is given by user bin tcl-sh. One thing I would like to mention here that you can execute these things as shown in the tcl, or in case you do not want to store the output, you just want to execute, what you can do, we bring my mouse, you can just keep this section that is within the rectangular bracket, it will execute, and rest of this variable and printing on the screen will not be there, it will execute. So you can do this also, try at your end and let me know. So folks, we are done with this particular slide. Let's move on to the next slide. EDA automation use of exec. Now in this example, I will exemplify in a simple manner how this exec can be used in EDA automation. In this pink box, the code will go, and the black box, the output will come. Now folks, before beginning, one thing I would like to mention here. When you are practicing a tcl code or maybe a Perl code at your end, you do not bother about whatever message it is outputting, or it got stuck, it will crash and it will give some output. You have plenty of time to debug and rerun. However, when the situation comes to a crucial point, that means you are writing automation inside any VLSI company, there your script has to become foolproof. That means even if there is an error or something warning is coming, you have to also display it without crashing the script. That should be your intent. You may not be 100% perfect at the very beginning. However, with time, you can achieve this perfection. Now, let me start the script and you will come to know why I have given this little amount of introduction in this particular slide. Here, first our hashbang user bin tcl-sh is there. Next, we have the catch. Catch is another command in tcl. It evaluates a script and track exceptional returns. What is an exceptional return? This means rather than the intended execution, that means a success execution, it went to a error or warning. So those are exceptional returns. So catch is a tcl command that can be used to capture these particular situations and scenarios. In the coming example, I will have two cases where our intended script is running with success, and there will be another case where our intended script is failing. That means we intend it to fail and we want to capture the failure. So let's begin the script. Here is the use of the catch. We put it inside the if block and put it inside a rectangular bracket catch. Then we write the exec command. Here the syntax is different. Here we have the curly bracket inside which we keep the exec and the subsequent command. And once we close the, let me bring my mouse. Once we close the curly bracket, we have a rate that is return variable. It corresponds to catch. If something unusual comes in, this return will catch that. And here we close it. So here I just give a put inside if block 1 just to have the location from where the output is coming in our output. Next, I print the return variable, whatever it is. Next comes the else block.
what we have in the else block? The return status, then catch, then exec, then pwd. So you can see here that we have used it like this fashion, and we write inside else block 1. So if block 1 and else block 1 means it's the first set of if-else condition, and we print the return status, and we close the else statement. Let me bring my mouse. Now, this case, this pwd will easily execute by the exec command. We know it. We have already done it in the previous example. Now, here our intention is that this execution, the if block will not return anything. Instead, it will go to else. So, if we want a success case, we will put inside the else. And if the failure has to capture, it has to capture in this one. The if. This is the way we are doing. So, this is the example where we are dealing with the successful execution. And now let us come to the next example, that is another if-else block. Here, if, right, catch, exec, then cd, then user, bin, tcl-sh and abc. So we know very well that this is a binary tcl-sh, and we cannot have a directory inside a binary. So this is obviously going to fail. So forcefully I am failing it, and that's why I have kept in the first if condition here. That means the if block, not the first one. This is the first one, and this is the second if block. In this case, I have forcefully failing this execution to see what return is coming from the catch statement. So here it is very similar. Catch, here it is catch, here is the execution, and here is the return. So next, I'll print it inside if block 2. This is the second if-else block, and I print the return value. I start the else, then we print the inside else block 2, and we execute in the similar fashion. Here also we have executed, and here also we set, then return status, and then catch, exec, whatever it is. And I close the else block here. Now, here you can see our first block, the if statement is here. The code execution will not go here. Instead, it will go here. And the second case, we know definitely our code execution will enter into this and will not enter into this. So both the cases will have the output. Let's have the output. So first it prints the inside else block 1. So as we thought, it would not go inside the if. Instead, it will go into the else. So it has inside the else, and already it has executed. So return status is 1. Here the return status is 1. And here it is, we are done for this first if-else block. Now let us go into the second one. Now, as we thought it will enter into the if block, as we are forcefully failing this command, it has entered into the if block, and with this return value array, it shows that would not execute cd, no such file or directory. That was our expectation, because inside a binary there cannot be a directory. So this way you have to understand this slowly and with time, why this catch and if and end block are there. This is because when you are writing a script for the EDA VLSI automation, right, your script should run smoothly, even any execution inside it fails. So you've seen that the whole tickle script has run, inside which we have conditioned it in such a way with the catch command that even there is a case where it is failing, the script is not crashing, the script is executing perfectly, and finally it is printing out the message here. So this way, obviously you can print the message with a warning tag or error tag, or you can print it with for the std error, or is okay std out, whatever you want to output. So you can use that. That is a kind of advanced level application, so I am not covering it here. You can explore by yourself. In case you have trouble, let me know, I will show an example. So here we are done with the EDA automation level use of exec, the way or the fashion the exec command should be used with catch inside the EDA VLSI automation. So guys, this is a very important slide and we are done with it. Let's move on. What is eval? First here, tickle allow new command creation and execute them while running a tickle script. You might be wondering, okay, what you are telling. If you have learned C, remember that in C there are macros which you can define inside the code and you can use them later on, right? So this is allowed in C, the macro creation and using the macros. So you can just have a similar feature in tickle, which is eval, but it is not a macro. It is not called a macro, but the way of application is kind of that. Typically, a tickle command is defined as a list of string where the first string is a command or a procedure. So it could be a tickle command or a user written procedure, okay? And the rest of the part of the string will be the arguments to that command or procedure. Any string or list which meets this criteria can be evaluated and executed by the eval command. This means we are executing custom command that is written by you
inside the tickle using the eval. And previously in exec what we have done, we have executed our external program. So this is a basic difference. We'll come to the details later. Let's go on with the bullets. In VLSI IDE automation, you need to have a set of commands which you need to repeat several times in your EDA tool shell for either design or analysis. So you can club a set of commands under a particular shorthand. You will come to know the example how that shorthand is created and execute those set of 3, 4, 5 tickle commands in one go with the eval. So this is the beauty of eval. So let's move on to the examples. Simple use of eval. Here goes our code. Here it will be our output. First line starts with hashbang user bin tcl-sh. Next, we have a short comment here inside the script. Define a shorthand for a set of tickle commands. Set cmd puts hello world. Here, first thing what we are doing, let me bring my mouse. Here, this cmd command is right. This is not a command. We have set a variable cmd and with just list of strings. So you remember this is a list, right? Here, first one is a tickle command puts and the next thing is a hello world. So this entire variable is capturing a list where the first one is tickle command itself and the next one is its argument. So this is where we are shorthanding. Okay, this is only a single tickle command we are talking about here. Next, we will come to the complex ones. So once we are done, we can execute it any number of times later in this particular script. How we do it? Eval then $cmd. Now let us go to a more complex kind of command. We are using the same name, set cmd, and here first we write set output exec which tcl-sh. Wait. Do you see that we are using already exec here inside eval? Exec we have already learned. Yes, we can use it. Next, we print the output. Here I close it. So here inside this particular variable, there is a list of strings. Here this one and this one. Okay, they will be flattened or whatever, however tickle internally manages them. But better way for our writing and understanding, we should write in this way. The first command and then the second command, and we maintain this curly bracket position so that we understand its set of scripts. And then we use the eval $cmd. So once we execute, what output will get? For the first one, it is a simple one, puts hello world, so it gives the hello world. Next, it executes it first, while inside it execute the exec, okay, and from there it gets the output, and then the next command it prints that output and we get user bin tcl-sh. So this is a very simple to understand example of eval. I think you have grasped it. Let's move on to the next slide. Repetitive use of eval. Now, this is again a very simple script to understand. In pink box, our code will go in, and in this black box, the output will be shown. Now, I have kept this very simple. In actual VLSI IDE case, this may become a complex or something like that. I am not going into the example right now because every use in VLSI IDE automation is a case by case, and hardly there is a generic example I can give you. So you can use it for your own goal or the goal of the script, or you have been asked to do it. Now, for this case, let us learn it simple way so that you can take it to the advanced level and do it. So learning is the first thing. Let's learn it. First line, as usual, hashbang user bin tcl-sh. Then we give the set I 0. We set the variable I or initiate the variable I with 0. And next what we do, we set this particular variable with the command with the list incr then I. So this is for our eval purpose, right? So that's why we are letting a set of strings to use it like a command, and we know incr is a tickle command which increases the value of this variable by 1. We have shorthanded it with this one. Next we do execute it any number of times later in the script. Now we are going to see this number repetition simply by a while loop where $i less than 20. So I will increase up to the value 20 where it stopped. And there I print it I equal to $i. What I use in the next command, eval.cmd incr. So this will keep on repeatedly used, and this value will keep on repeatedly incremented, and the counter will get incremented, and finally we close it here. So you can easily recall this is a very common example for the while loop when you learn the while loop first time, and I am using that to make things easier for you. So
once execute this script, what comes as output? Obviously 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 and finally 19. So it has run up to 19. It started from 0. So 20 counts are there and it has stopped there. So 20 times this increment counter has executed and executed using this eval command. And here this counter is checked every time at the beginning of a loop, and once it dissatisfies this condition, the loop stops. So here once it reaches 20, it stops because I should be less than 20 and it stops. So this way the eval command can be repeatedly used. This is one example. There could be any number of examples. Coding can be go any direction based on your requirement. That's why it is coding. But you need a kind of seed thought to understand the basics. So I have presented it to you. So I think we are done with this particular slide. Let's move on. Let us summarize now. Eval and exec are the ways to execute internal macro and external binary respectively. Although the word macro why I am using just to relate with your C concept where we have used the macro. However, it's not a TCL concept, just to remind you. And eval is for internal and exec is for external. And also we have in this tutorial, we have seen that we are clubbing the exec inside eval. So that is already I have shown. Eval provides a way of shorthand to bunch of TCL commands clubbed together. Fine, we can club multiple TCL commands and execute in one go using eval. Exec provides a way to call external binaries within, that is from within TCLSH shell. In case of EDA tool, it will be the tools shell. So folks, here we have done the comparison of eval and exec and we have clubbed them together, and finally we are summarized with our learnings. So I think we are done for the day. Let's move on.
Hey guys, welcome to the 24th episode of Q&A. In VLSI, we come across log file every now and then from various EDA tools. The part of the log file that bothers us most is the warning and error section. Viewer Ajay Ramagiri has asked in the 5th episode of TCL in VLSI series how to print only the warnings from a given log file using TCL. So in today's episode, we are going to demonstrate a short and sweet TCL code to extract the warnings from a EDA tool log file. This code can be sandwiched even inside your EDA tool very own TCL shell code. So gear up and enjoy the learning experience.
Hey guys, welcome back to the computer screen. We are discussing viewer's question. Ajay Ramagiri has asked that how to print only the warnings from a given data.log file. He has asked this question in the 5th episode of TCL in VLSI. So there I have discussed the file IO, that means input output of a file. So without any further delay, let's begin. So in today's episode, we will cover the below points. Pick up the log file with warning message. This is because we have to pick a right log file which has a sufficient amount of warning message. Understand the code flow and organization. So here we will discuss how the code is organized and how it is functioning. Writing the TCL code. I'll go line by line of the TCL code. Code execution in terminal, live demo. So after that, the discussions are done. We will go towards the actual terminal where we will execute the code and see the output. That's the menu for today. So without any further delay, let's begin. Log file with warning and message. When this question came, I was doing some research on the internet to find out a particular log file which is not written by me, however, which is an actual log file, and that log file is containing different types of warnings. I found one, and in that log file, these two type of warning messages are there. So this log file is not from any EDA tool. This is a general log file, and basically there is no difference in a log file because it's ASCII, that is a text file, and that will contain warning in different formats. So here in the first snippet, you can see that, let me bring up the mouse. So here you can see this warning is followed by two messages. So this is a one type of warning. The second type of warning, you can see there are two separate warnings are there. However, these are sufficient in one line. The log file I picked up from the internet as these two type of warning. Our purpose is to filter out all these two types of warnings from the actual log file. So we're done with this slide. Let's move on to the next slide. Code flow and organization. First, in the code, we will open the log file for reading, and in this direction our flow is going on. Next, we will parse line by line the file. Then
While parsing line by line, we will match the lines with the regular expression with case insensitive touch for the keyword warning. And finally, whatever we get in this process, we will output that data in screen, that is in terminal, as well as we will dump the details in another log file, which is different from the input log file, that is a output log file, where we are filtering the warning messages only. So this way, our flowchart is working for the code. Now we are done with this slide. So let's move on to the next slide. Writing the tickle code. Here in this pink box, go line by line of the code. First, we start the code with the hashbang user bin tcl-sh, which is the tickle interpreter. Next, we use the file handle fread to open the error.log in read mode. You can see there is R. Now, this error.log I have picked up from internet. The link I will also provide you so that you can wrap this log file at your end and you can try out the same code. We open another file handle, that is fwrite, for writing output log file, that is a warning.log. This is a log file that we are creating and we are opening it in a write mode. That's why the flag is W. Then we use the while loop. I have already described this method in the 5th episode where this question was asked by the viewer, and we are using the same kind of setup with the while loop here. Till the end of file, we are iterating on the file handle. Next, we get each line from the file handle and then we trim out the new line character using this particular tickle code, that is a string and trim right. Character that we are removing is \n, that is a new line character. Next, once this trimming is done, we are taking the first regular expression match and we are using the no case. That means whether it is in a small caps, whether it is in upper caps, in both cases, or it is in a mixed cap. So in all the 3 cases, the warning keyword will be matched in the current line. Next, we print the line on our screen, whichever matching we are finding. As in the code flow and organization slide, I have said that we are dumping the code both on the screen as well as in the output file. Next, we write the same line to the output log file. Next, we write the same line with the file handle fwrite inside the output warning.log file. Here, our first if block is closed. Next, we search for the keyword message. We do a regular expression matching for the keyword message because I have shown you in the first type of warning, each warning line is getting followed by a line which contains the keyword message, which corresponding to the warning only. This is additional effort that we have to do. Now we print the line in the terminal and then we write the same line in the output file with the file handle fwrite and we close it. And here we close the while loop. Finally, we close the file handle fread and we close the file handle fwrite. So this way our code is written. We are done with the explanation of the code here. Let's move on to the next slide. Code execution and live demo. So it's our time. Let's move on to the terminal where we will do the actual hands-on operation on the code and see the output. So here we are in the terminal and I am in the directory where the code is kept. So you can see this is the error.log. Again, I am emphasizing that I'll provide this link in the description of this video so that you can get this log file. So let me show you first log file. So you can see the log file is huge. It has 99 lines. And inside this, if I search, I have searched the keyword warning here inside this particular file. I am using right now the gvim text editor and here you can see warning, 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 and here you can see warning. So these are 2 types of warning. You can see this one warning is followed by 2 lines and again the next warning is followed by 2 lines. You can see that here you don't have the messages allied to this. At the end we see another type of warning which are single line only. So this 99 lines, our program code will parse and only extract these lines and the corresponding 11 lines from the warning. And let me open the tickle code. This code I have already explained to you in the slide, so I'm not going here in details. Just I shown you the code is the same as that we are already discussed. So let me quit this one, and so you can see that This has the execution permission. Now I will execute the code, and for that I am using the / operation and I am hitting enter. You can see the program has now extracted the warnings along with the messages as well as the warning which do not have the messages. So these warnings have messages attached to each warning, and these two warnings which are single. Now I will do a ls. You can see our output warning.log file is also created. Let me open it. And once I open it, you can see side by side the same thing which is printed here in the screen. It is also dumped here in the text file. It is very important, folks, because if you create an output file, that will help you in long term. If the message goes in the screen and suddenly the terminal is closed, you will not be able to recover the message. However, if a file is written in the disk, even the terminal is closed, you can open a new terminal, go up to that path and open this particular output file so that you have your data intact. I'll advise you to keep this practice to dump an output file whenever you are trying to extract some data. This habit will help you in long run. Here we are done showing the output to you. Let me close it, and here we reached the end of today's episode. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in comments in the comment section down below.